Good morning and welcome to the first general session of this virtual edition of the National Hurricane Conference. While we're disappointed the 2020 conference could not be held as scheduled, we're very pleased that a number of speakers and session organizers stepped up to the plate to make this virtual conference possible. We hope the information you take home from this limited conference will help you successfully navigate a potentially active hurricane season that's already been aggravated and exacerbated by the COVID-19 pandemic. My name is John Wilson, the conference chairman for this year, and I'll be serving as the moderator for this session. Our first speaker, who is going to give us an indication of what our hurricane season may look like this summer, will be Phil Klotzbach. Phil is a research scientist with the Department of Atmospheric Science at Colorado State University. He received his PhD in atmospheric science from Colorado State in 2007. Phil's been employed with the Department of Atmospheric Science for the past 17 years and was co-author of the Atlantic Basin Hurricane Forecast with Dr. Bill Gray through 2005. He became first author of the seasonal hurricane forecasts in 2006. Bill developed his 2-week forecast, currently being issued during the peak months of the hurricane season between August and October. He has published over 24 articles in peer-reviewed journals, such as the Journal of Climate and Weather and Forecasting. Phil graduated from the Bridgewater State College with a BS degree in geography in 1999, and then attended Colorado State University, where he received his master's degree in atmospheric science in 2002. Phil, thanks for getting up so early this morning. I know you're on the other side of the coast. The screen is yours.
Thank you very much, John. Just waiting to get the share screen. Perfect. All right, here we go. Excellent. Well, I'd like to thank all of you for tuning in this morning, and thanks so much to the National Hurricane Conference for having me present today. I'm going to talk with you about the Atlantic Basin seasonal hurricane prediction and the outlook for the 2020 season. As I'm sure all of you know, the hurricane season officially started yesterday. We've already had 2 named storms and a 3rd tropical depression brewing in the Bay of Campeche, potentially having some significant impact coming up into Texas and Louisiana. So certainly the 2020 season is off and running. As John already mentioned, I did have the great privilege of working with Dr. Bill Gray for many years, and he was a great friend of the National Hurricane Conference and just a tremendous scientist and visionary, really, in the field of tropical meteorology. In addition to the seasonal hurricane forecasting, which he pioneered back in the mid-1980s, he also made fundamental contributions to tropical cyclone genesis, structure, intensity change. He was an incredibly charismatic person, and hopefully many of you had the opportunity to see him present at one of the previous National Hurricane Conferences. If you're interested, we did actually publish a paper on Dr. Bill Gray in 2017, where we highlighted both his scientific research legacy as well as his contributions in terms of contributing to having lots of PhDs and master's students, which are busily involved in the hurricane research and typhoon research around the world. But Bill Gray was certainly a visionary when it came to seasonal hurricane forecasting. And he was also a real fan of philosophy. He gave me several books to read on philosophy, but one of his favorite philosophers was the great New York Yankee catcher Yogi Berra, who once stated that it's tough to make predictions, especially about the future. And while I think you could certainly agree that that's the case, whether you're predicting the outcome of a sporting event or you're predicting overall hurricane activity, predictions are really, really challenging. But one other statement that Yogi Berra made that I think is very prescient when it comes to seasonal forecasting is you can see a lot by looking. And that was really Bill Gray's way of doing research. He was an empiricist. Basically, where does the data lead you? Look at the data, and the data will show you basically what you're looking for. And so the idea was Bill Gray was teaching tropical meteorology in the early 1980s, and he noted that when you had El Nino conditions, warmer than normal water in the eastern and central tropical Pacific, you tended to have fewer hurricanes in the Atlantic. And this was a pretty interesting discovery because no one had really looked at being able to forecast hurricane seasons before. But he said, well, we usually have a little bit of predictability with El Nino. We know around by June 1st in general, we're pretty confident as to what El Nino is going to do. And if we have that information, we can use that to issue a seasonal hurricane forecast. And so the idea was, well, you have these conditions, El Nino reduces Atlantic hurricanes, but the big question obviously is why? Why would something going on in the tropical, eastern, and central Pacific impact hurricanes in the Atlantic. And after additional research, he found it was through alterations in what's known as vertical wind shear. So if you think about the Atlantic Basin, your low-level winds typically blow out of the east, and your upper-level winds blow out of the west. When you have an El Nino event, it increases upper-level westerly winds, which increase your levels of vertical wind shear. Too much shear is detrimental for hurricanes. It tends to tear them apart and makes them less likely to develop and to intensify. Alternatively, when you have La Nina conditions, which is cooler than normal water in the eastern and central tropical Pacific, you tend to have less of that overall vertical wind shear, and you tend to get more active overall hurricane seasons. So this is one of his first big relationships that he discovered, one of the first tools that we started using when CSU started the seasonal hurricane forecast all the way back in 1984, and we still use today. Obviously, there's a lot more than El Nino that goes into the hurricane seasonal forecast. We have extensive hurricane data going back to the mid-19th century, but it's pretty accurate since around 1950. We also have good data of water temperatures and pressures and things like that going back to 1950. So we use these historical data sets and basically look for precursor signals, basically what sets of climate conditions preceded active seasons, and alternatively, what sets of climate conditions preceded inactive seasons. And we do find that certain sets of conditions tend to reappear, one before active and the alternative, or the basically opposite set before inactive seasons. So this figure basically shows what you tend to get during very active hurricane seasons. It's the 10 most active seasons since 1950, minus the 10 least active. And you do see pretty coherent sets of water temperature anomaly patterns, such that when you have colder water in the eastern and central tropical Pacific, indicative of La Nina conditions, you tend to get more active seasons. Also, you see warmer water in the Atlantic. Yellows and reds indicate warmer water. And obviously, hurricanes live off of warm ocean water, so more of that warm ocean water needs more fuel for the storms. It also tends to be associated with lower pressures and a more unstable atmosphere, all of these conditions which tend to be associated with more active seasons. And as we move in and talk about the 2020 hurricane season, we'll talk about some other predictors that we look at for the seasonal forecast. So we did issue our first forecast in early April. We'll actually be updating that forecast on the 4th of June, so coming up here in just a couple of days. The seasonal forecast, I don't anticipate any large changes. We'll likely be increasing the number of named storms a bit, since we'll most likely have 3 named storms by the time Thursday rolls around. And also maybe increase the number of hurricanes a bit, just given overall the season does look even a bit more active than what we anticipated in early April. So we have already had a couple of storms. We had Tropical Storm Arthur, Tropical Storm Bertha. We right now have Tropical Depression 3 in the Bay of Campeche. And so the question that often gets asked is, if you have early season storm activity, does it really relate to overall how much storm activity you're going to get during the season? And the answer really is no. Whether you get storm activity in May and even into June doesn't really correlate with the rest of the season. And that's because these storms tend to form in the subtropics. They don't really necessarily correlate really with what you're going to expect overall for the hurricane season. So this figure shows a plot of the day of the first Atlantic named storm formation paired up against seasonal accumulated cyclone energy. And you may have heard accumulated cyclone energy, or ACE, referred to before, especially with NOAA scientists. Basically, ACE is an integrated metric that accounts for the frequency, the intensity, and the duration of storms. So very, very short-lived weak storms, like Bertha that just formed a few days ago, that was a named storm for just a few hours, generates very, very low levels of ACE, whereas a long-lived major hurricane, such as Hurricane Dorian or Hurricane Irma, generates a tremendous amount of ACE. But if you look at the relationship between the first named storm formation date and overall ACE, it's a very, very weak relationship. So early season storm activity doesn't really tell you much about how active the season is going to be. The only time it actually does is if you get storm formations, and especially in July, east of the Windward and Leeward Islands in the tropics, that's often a sign of an extremely active hurricane season. However, it's more of a sufficient condition than a necessary one, because there's certainly been plenty of seasons with very little storm activity in June and July, but still ended up very, very active overall hurricane seasons. So our initial forecast we put out in early April was for an above normal season. An average season has about 12 storms, 6 hurricanes, and 3 major hurricanes. The 2nd of April, we called for 16 named storms. Of those 16, 8 becoming hurricanes, and of those 8, 4 becoming major hurricanes. An average season for ACE has about a little over 100. We're predicting 150, so about 140% of the average hurricane season in terms of ACE as well. So we do a variety of different techniques to come up with our forecast. One technique that we use is a statistical model. And so a statistical model uses techniques very similar to what Bill Gray used back in the early 1980s. What we use is hindcasting. So basically, which regions would have worked well at forecasting historical hurricane activity. And in this case, we're using high resolution data, which goes back to the early 1980s. So in this case, we're trying to say which regions would have worked well at forecasting hurricane activity from 1982 to 2019. And so we use a total of 3 predictors, 2 that kind of assess the overall conditions in the Atlantic Basin, and 1 that assesses conditions in the Pacific Basin, giving you a better idea of what El Nino is going to do. These 3 predictors in combination explain a significant amount of variability. Here's a plot of showing how well this model would have forecast accumulated cyclone energy back to 1982. The blue line is the observed values, the red line is the hindcast, and you can see overall the model does a reasonably good job. There are some years where the forecast busts. 2013 is a year that was extremely hard to forecast, and still we really have a hard time anticipating how quiet the 2013 season would have been. But overall, you see the model does a reasonably good job, explains about 40% of the variability. This is what you would expect. I mean, you're still 2 months prior to the start of the hurricane season and 4 months prior to when the season really ramps up. So there's likely to be a considerable spread in these early seasonal forecasts. Our statistical forecast for 2020 was for a very active season, even a little bit more activity than we forecast, but a very active season coming out of the statistical model. Just to give you a little bit of foreshadowing, here's our June seasonal forecast, the statistical model for that. We use a total of 4 predictors, 2 in the Atlantic and 2 kind of assessing the conditions overall in the Pacific Ocean. So our skill in early April, we can get about 40% of the variability. In June, we can get about 50% of the variability, and that makes sense, right? You're 2 months closer to the start, or you're basically right at the start of the hurricane season. The hurricane season really ramps up in August, so you're about 2 months prior to when the season really ramps up. So while the hurricane season runs for 6 months from June 1st to November 30th, over 90% of your major hurricane activity occurs from August through October. Major hurricanes being the category 3, 4, and 5 hurricanes, winds of 111 miles per hour or greater. So here's the hindcast skill of our June model, which we'll obviously be discussing in great detail when we release our seasonal hurricane forecast update on June 4th at 11 a.m. Eastern Time. We do have some new techniques that we're using, and so here what I'm showing you is the predictors that go into our August statistical model. This is the one that we issue at 1 August. This model historically has the highest levels of skill. And so the question is, why am I showing this on the 1st of June? Well, the idea is that we can't obviously know what the conditions are going to be like in July, but we can use a climate model to forecast what the large-scale conditions are going to be like during July. And obviously, the model can't tell you exactly what the weather is going to be like on a specific day at a specific time, but climate models can forecast overall monthly averages with what I thought was surprisingly good skill. These models have hindcast data going back to the early 1980s, so we can verify and see how well these models have done at forecasting large-scale conditions. So what we do is we use a climate model to forecast the large-scale conditions in July, and then we use the historical relationships between those July conditions to then forecast ACE, again, an integrated metric that we use for our seasonal forecasts. So here's the skill of the model in early April. Since the model takes about 10 days to initialize, we use the model from March. And you can see the model does a reasonably good job. You can get a correlation of 0.6 when you use the statistical dynamical model. So using the ECMWF climate model to forecast the large-scale conditions, and then using the forecast of those conditions to then forecast ACE. And that model is also a very aggressive climb for a well above average hurricane season in 2020. If you combine our typical statistical model with the new model using the climate models to forecast, so you have 2 different models and you average them together, you get even better skill. You can explain about half the variability in early April, which I think is pretty good. I'm very happy with that result. And hopefully this will help with improving the skill of our real-time forecast issued in early April. Since historically, the skill of our forecast issued in early April has been fairly low. The skill of our forecast improves as you get closer to the peak of the season. So typically the June forecast has more skill than April, and then the August forecast has more skill than June. And similar to the way that your weather forecast for tomorrow tends to have more skill than, say, your weather forecast 1 week out. We also use analogs, which basically are the years in the past that had conditions most similar to what we currently see, as well as what we anticipate, for the 2020 hurricane season. So in this case, we selected 5 analogs. Those 5 years were 1960, 1966, 1980, 1996, and 2008. And you can see that 4 of those 5 years had ACE above 100, so 4 of those 5 years were above average seasons. 1960 was overall kind of a near average hurricane season. And so one thing I like to point out, though, with analogs is what we're looking at is overall large-scale conditions, how similar those are to what we've observed, or how similar those are to what we think we're going to see during the peak of the season. This isn't to say that just because 2008 is an analog that we expect to see another Hurricane Ike. We can't say when or where the storms are going to track during the hurricane season. So one thing we are unveiling with the 2020 forecast is probabilities of exceedance. And the reason that we do these is because with the seasonal forecast, we give our best estimate of what the numbers are going to be. But obviously, as you all know, there is uncertainty associated with these forecasts. So what we've done is basically calculate the historical probabilities and the historical errors of the seasonal forecast. And then we use that to basically kind of give you an idea of what the spread is. And so what we do is we try to basically give you the 70% confidence interval, which is similar to what NOAA does when they issue their seasonal forecast. So you can see that while we're predicting we predicted an ACE of 150 with the early April forecast, there is considerable spread. There's a 70% confidence interval that it falls somewhere between basically a dead-on average season and a hyperactive season. An ACE over 200 would be extremely active. So overall, you can see that we are forecasting an above-average season, but there is some spread in these outlooks. Obviously, as you get closer to the peak of the season, the spread does shrink somewhat because the historical forecasts have higher levels of skill. So here's the ranges, the similar 70% ranges to what NOAA provides. So with named storms, 16 named storms, the uncertainty range is 13 to 19. For hurricanes, 6 to 10. But obviously, that's some of the stuff we did in early April. Lots obviously changed since then. Here's a map showing your current sea surface temperature anomalies. So sea surface temperature anomalies are basically what the water temperatures are like compared with normal. So an above normal water temperature or an above average sea surface temperature anomaly is highlighted in orange and red. Blues indicate colder water, as you would expect. So the blue box highlights the region that we assess for El Nino conditions, while the red box is known as the main development region. So that's where most of the strong hurricanes develop in the Atlantic Basin. So you can see there is some blue showing up in the eastern and central tropical Pacific, and most of the Atlantic is warmer than normal, although there is a portion of the tropical Atlantic that only has near average water temperatures right now. So we have seen a lot of cooling in the eastern and central tropical Pacific. We're kind of on the brink of an El Nino event this past winter into early spring. We didn't quite reach the El Nino threshold, but it was fairly close. But if you look at the panels on the left, you can see a very significant downward trend in all the regions since early April, with many of the regions now going below zero. So this is basically from west to east across the tropical Pacific. So Nino 4 is in the central tropical Pacific. Nino 1 and 2 is right off the west coast of South America. If you look at upper ocean heat content anomalies, those have also gone down dramatically. And upper ocean heat content anomalies tend to be a good precursor signal for what's likely to occur, because not only is it important what the water temperatures are at the ocean surface, but also what the water temperatures are deeper down in the ocean. And you can see that those water temperatures are fairly cool, going down about minus 1 degree Celsius or 2 degrees Fahrenheit. And so half a degree Celsius is what you need effectively to have that's the official threshold that you need for NOAA to declare either El Nino or La Nina. So when it's half a degree warmer than normal, they declare an El Nino. Half a degree colder than normal, they declare a La Nina. And that's if those temperatures persist above or below that threshold for a specific amount of time. But you can see Nino 3.4 is down about minus 0.5. So if that, say, were to persist for a couple of months, NOAA would likely declare a La Nina present. And obviously, La Nina tends to increase Atlantic hurricane activity because, as we talked about earlier, it tends to reduce your levels of vertical shear. So one thing that we look at when we're looking for El Nino or La Nina is what the low-level winds are like. Because basically, when you have westerly winds blowing across the tropical Pacific, it tends to force El Nino. When you have easterly anomalies, it tends to create conditions more likely to support La Nina. And so if you look around 180, which is the international dateline, you look for the month of June, you see a lot of blues in the forecast, which means stronger than normal winds, which means tending to favor more La Nina conditions. So I think overall, certainly the odds of El Nino are very low for the upcoming hurricane season. Here's the official forecast from the U.S. government. This should be updated here in the next few days. In early May, they gave the highest chance of neutral conditions for August through October. Personally, I think we're more likely potentially to be at least into weak La Nina conditions by August through October, based on the Nino 3-4 index, which is averaged over the central tropical Pacific, probably being at the minus 0.5 degrees Celsius threshold during that time period. There are a whole pile of models that issue forecasts for El Nino. As you can see on the right, it's kind of like alphabet soup, a whole pile of dynamical models, a bunch of statistical models. And the average of these models is calling for neutral conditions, a few more calling for La Nina than El Nino. Dynamical models are full physics models, so there's the models that have all the equations of the atmosphere and the ocean in them, whereas statistical models are simpler models in a lot of ways. However, at this time frame, you actually can get a decent amount of skill from the statistical model, so I wouldn't necessarily discount what those are going to say as well. But overall, you can see El Nino, it seems to be very unlikely for the peak of the hurricane season. If we focus on the tropical Atlantic, you can see that the Atlantic in general is warmer than normal. The subtropical Atlantic is quite warm. The Gulf of Mexico is warm. That's where Tropical Depression 3 is in the Bay of Campeche. So just around 20 degrees north and 90 degrees west down in there. You can see very warm waters in that region. The Caribbean is also warmer than normal. So the next plot that I'm going to show you is a correlation map. So basically, here's a correlation map between June water temperatures and accumulated cyclone energy, or ACE. So basically, if that water temperature pattern is present, that tends to be associated with very active seasons. So the highest correlations are off of the Iberian Peninsula. When the waters there are warm in June, it tends to be associated with very active hurricane seasons. So if you look at the plot here, you can see that those water temperatures tend to be pretty warm in that region. And the reason why water temperatures off of Iberia are important during this time of year is because when you have warm waters there now, it tends to force lower pressure, which tends to force weaker winds blowing across the tropical Atlantic, which tends to cause anomalous warming in that region. So the region warms up faster than normal in the deep tropics. And again, that's obviously what we care about during the peak of the season, because if the waters are warm in the peak of the season in the deep tropics, it provides more fuel and a more unstable atmosphere for hurricanes. So here's the latest forecast in the Climate Forecast System model, which is the U.S. government, NOAA's model, and it's forecasting overall a weak La Nina event and fairly warm water in the tropical Atlantic. So this also would tend to lead towards overall a pretty active hurricane season. Now, as I mentioned before, you can't say months in advance when or where storms are going to strike, but overall you can give some probabilities of U.S. landfall, and that's what we do here. Is basically more active seasons tend to have more landfalling hurricanes. So if you're interested, we have a website where we provide probabilities of United States landfall as well as Caribbean landfall based on historical probabilities and then adjusted by our latest forecast, with the idea being that more active seasons have more landfalling hurricanes. So here are the probabilities for 2020. The numbers on the right-hand side in parentheses are the average climatological probabilities, while the numbers to the left are the probabilities for the 2020 hurricane season. So you can see the probabilities are elevated again because we're predicting an above average Atlantic hurricane season in 2020. We also have probabilities for each state being impacted by a hurricane. This is slightly different from a landfall. Basically, the Hurricane Center has a database of every hurricane that's made landfall in the past. And when the hurricane makes landfall, it assesses which states receive sustained hurricane force winds. And that's how it defines the hurricane impact. Basically, the idea is that a hurricane may make landfall in one state, but bring sustained hurricane force winds to other states. And obviously, if it's a storm like Hurricane Hazel in 1954 that made landfall right atop of the South Carolina-North Carolina border, you obviously would have to pick one state for where it made landfall, but obviously it significantly impacted both states with sustained major hurricane force winds. So we have probabilities for each state from Texas to Maine being impacted by a hurricane. You can see the probabilities for Florida. On average, there's about a 50-50 chance in any year that Florida receives sustained hurricane force winds from a hurricane. This year, the probability is higher at about 70%, again, because we're predicting an above average Atlantic hurricane season. So these forecasts aren't stagnant. We do update them. Our next forecast comes out again on the 4th of June. We'll issue a short update on the 7th of July and a final full forecast on the 6th of August. And again, while August is 2 months into the hurricane season, historically over 90% of your major hurricane activity occurs after the 1st of August. If you love seasonal hurricane forecasts, we have a website, seasonalhurricanepredictions.org, which is spearheaded by the Barcelona Supercomputing Center and ourselves at CSU. We have over 25 different groups submitting seasonal hurricane forecasts to this website. These are all done by credentialed meteorologists and climatologists and include obviously a bunch of universities, private sector weather companies, as well as government agencies. One thing I do like to point out is that there's actually more seasonal forecasts being issued by universities from landlocked states than universities that actually are in states bordering an ocean. So take that as you will. But they used to ask Dr. Gray why he issued seasonal forecasts from Colorado, and he said it's because the storm surge can't get you at 5,000 feet. So here's the way the website currently looks, seasonalhurricanepredictions.org. There's over 20 groups that have submitted their seasonal hurricane forecast so far. Most of the groups are calling for an above normal hurricane season. They're color coded by the agency. So blues are universities, purples are private weather companies, reds are for the government agencies. The orange dots are the average of the seasonal forecast issued at each lead time. And the red dot is the observed values to date. So the average of all the seasonal forecasts is for 8 hurricanes. Again, the average is about 6. The red dot is how many hurricanes we've had to date. And obviously, so far, we've had no hurricanes. And so with just the last few minutes, I wanted to talk about some other research I've been working on recently with some colleagues. And this is what predicts U.S. hurricane damage better, wind or pressure? And the reason I wanted to do this is because obviously we're all familiar with the Saffir-Simpson hurricane wind scale, but there's been a real kind of pushback against that scale. And I always say, don't pay attention to the category. There's a lot more that goes into hurricanes than that. And certainly I would 100% agree with that. And just to kind of give you an idea, the reason that we wanted to start looking at this is we have a case of 2 hurricanes. Hurricane Charlie on the right in 2004, Hurricane Katrina on the left in 2005. Both of these obviously tremendously impactful hurricanes, but Charlie was a Category 4 while Katrina was a Category 3. Charlie had a much higher pressure than Katrina. And the reason why pressure is important is because it's more of an integrated metric that accounts for kind of the overall structure of the storm. So if you have a very intense storm that's small, it will have a high pressure relative to its wind because the winds act off of the pressure gradient. So if you have a very large storm like a Sandy, the pressure gradient was spread out over a very large area. So even though the pressure, or even though the winds weren't particularly strong and the pressure was extremely low, you had a very large storm, and that's significant for how much storm surge a storm is going to generate. Also, the area of the damaging wind is also much larger. So in this case with Charlie, we had a storm surge maxed out at about 7 feet. With Katrina, about 28 feet. Now, obviously, Katrina, we all know about the levee failures and everything in the New Orleans area, but obviously, even if the levees at 100% held and New Orleans had been mostly spared, it was a tremendously damaging storm in Mississippi. We had over 25 feet of storm surge, several hundred fatalities along the coast from Katrina, from a Category 3 hurricane. So the question is, what does work better at predicting damage, wind or pressure? As I mentioned before, it's a better robust measure of overall storm intensity, but it's also easier to measure than wind, both with aircraft, because when you're flying a plane through a hurricane, trying to sample exactly the strongest winds is a real challenge. But with pressure, if you have a well-developed hurricane, you fly a plane through the hurricane, you drop a sonde in the eye, you know the pressure quite well. You can also just estimate the pressure pretty accurately from when you fly through at about 10,000 feet. Also on land, it's incredibly hard to measure the strongest winds on land. Anemometers chronically fail. And also getting the 10-minute over ocean exposure, obviously that changes the instant the storm hits land, whereas a barometer doesn't even necessarily need to be outside. You can have one inside a house, but if you gorilla tape, say, a barometer to a bridge or something, you can get a very accurate measure overall of the pressure of the storm. And Josh, who's going to be talking later on, he goes out, and he doesn't even bother trying to measure wind. He just measures pressure. And I think these pressure measurements are incredibly helpful for judging overall how strong these storms are. So here's an example of kind of why we pulled away from using the maximum sustained wind, because if you look at the damage, this is from 2007 to 2019. Here's this figure showing ranks of damage versus ranks of wind. And the reason we use ranks is to kind of separate the impacts of outlying events. And you can see here, there's a whole lot of spread. So ranks is you increase the rank, it's a stronger storm. You can see there's a lot of spread in terms of the damage versus the wind. Whereas if you look at the same figure over the last 12 years for pressure, you see a remarkably good fit. It's not perfect, but obviously nothing is going to be perfect. There's a lot of other factors that go in as well. Obviously the speed of the storm, and especially also where the storm makes landfall. If the storm makes landfall in a densely populated area, all else being equal, it's going to cause more damage in a more sparsely populated area. But overall, you do see a much better relationship with pressure than with wind going back to 2007. But obviously that's great, but that's a very small sample size. Let's look at this over a longer time period. So what we've used is normalized damage. So basically taking the damage that was done at the time and then adjusting it to today's values based on population, wealth, as well as inflation, because obviously the population has grown tremendously in coastal areas and as well as around the globe since 1900. And so if you look at the relationship between wind and damage going back to 1900, you do see a pretty good relationship there. The correlation is 0.66. There's obviously some spread associated with that. If you look at it with pressure, the correlation is significantly improved to 0.77. You do get a better relationship with pressure than with wind. And to me, it's remarkable that you can explain about 60% of the variability in the damage just by knowing the pressure. That's the one number you know. You don't know where the storm made landfall, how fast the storm is moving, how much rainfall it's dropping, just knowing the pressure. And I think a lot of that is, again, because you have a better idea of overall how strong the storm is. You have a better idea of overall the intensity of the storm, not just the sustained wind, but how large likely the storm is, the overall integrated strength of the storm. And we find that the relationship is dramatically improved from Georgia to Maine. The Saffir-Simpson scale historically has not worked very well from Georgia to Maine. It works much better. You can use pretty much either one from Texas to Florida, but for Georgia to Maine, the relationship you can see here is pretty weak for wind, but it's much better for pressure. And I think that makes sense because Georgia to Maine hurricanes, the storms tend to be growing in size. They're older storms. They tend to be starting to undergo a little bit of extratropical transition. So they grow, they get larger, they get sprawlier, and overall the winds may come down, but the pressures stay low, and overall they can still obviously cause significant impact. So pressure works much better than wind from Georgia to Maine, whereas they work about equally from Texas to Florida. So what we then did was we said, well, let's basically take the historical storms and recategorize them by pressure instead of wind. And so originally the Saffir-Simpson scale was just wind, and then Bob Simpson added pressure. And then when they removed the storm surge component from the Saffir-Simpson scale, they also removed the pressure component. So we said, let's put the pressure component back in. And the way that we assigned the pressure was we looked at the strongest intensity that each storm had back to 1979, and then said, okay, let's look and see how well the winds, basically how, so in the case of a category 1 and above hurricane, about half of all storms that get named by the Hurricane Center become a category 1 hurricane. So we said, what pressure kind of meets that threshold? So 990 millibars or 990 hectopascals is about half of all storms have a pressure that's that low or lower. Likewise, for a category 3 hurricane, 960 millibars and below. For a category 5, 925 and below. You can see those are pretty similar to what Bob Simpson initially assigned with his with the original Saffir-Simpson scale. So we said if we categorize hurricanes by pressure, we do actually end up with more major hurricanes, a little less than half of all hurricanes making U.S. landfall becoming major hurricanes. And here's a view showing how these hurricanes have changed using pressure as categorization as opposed to wind. You can see overall there are more increases and decreases, and a lot of increases along the East Coast of the United States. Again, because obviously storms along the East Coast tend to be larger, the winds come down, but the pressures stay low. In this analysis, we did include Sandy. Obviously, Sandy was officially post-tropical when it made landfall, but obviously Sandy was a hurricane just a couple of hours before landfall, and certainly is a prime example of when wind really didn't explain very well what the storm was doing. The winds with Sandy were fairly low given how slow the pressure was. The sustained winds with Sandy were, 70, 75 miles an hour when the storm made landfall, but it had an incredibly low pressure and obviously had a huge storm surge associated with it, and obviously also went into a very heavily populated area. So just to remember, this is Hurricane Katrina. It was a category 3 by wind, but a category 5 by pressure, and the storm surge with Katrina was mind-boggling, over 25 feet of storm surge associated with Katrina and portions of Mississippi. And then lastly, I just wanted to highlight, in terms of fatalities as well, pressure does a better job of predicting the number of fatalities that a storm is going to cause. And obviously fatalities is a huge issue in terms of, it's the wind, it's the storm surge, but it's obviously a lot about the rainfall too. So you certainly don't expect to get a perfect correlation with any one single metric. But overall, here's the correlation with wind. Here we went back to 1988 because as you go back in time further, the death totals just get higher for the same type of storm intensity just because of, poor storm warnings. We weren't as accurate with the forecast. The evacuations weren't as smooth. So, we're looking in the modern era. So you can see a correlation of 0.35 with wind, but 0.6 with pressure. So certainly a better predictor of pressure than with wind. So overall, we're advocating that we use pressure and look at pressure a lot more when we do hurricane forecasts and when we're assessing the risk that these storms are going to cause. Obviously, again, no one metric can perfectly do this, but if we're going to categorize hurricanes based off of one number that's available in real time, we argue pressure works better than wind, but obviously, you know, there's a whole lot of other stuff that's involved as well. So with that, I'd like to thank you very much for your attention, and I always like to finish with an admonition from Arago, who is a French scientist at the Paris Observatory in the mid-19th century, who stated that never, no matter what may be the progress of science, honest scientific men or women who have regard for their reputations venture to predict the weather. And so just to highlight, we will be putting out our next seasonal forecast on June 4th. Thanks to our awesome research group, we do actually have a new website, which should be coming online in the next couple of days. Here's a couple of screenshots from the new website. We're going to be including better kind of synopsis of the seasonal forecast, some new visualizations for the real-time tropical cyclone statistics piece. So this is not available yet, but it should be available in the next couple of days. So certainly when the seasonal forecast comes out, June 4th at 11 a.m., you'll hopefully have a new fresh interface to explore those forecasts, as well as a bunch of other cool stuff that a research group here at Colorado State is doing. So with that, thank you very much for your attention. I'll try to answer any questions. And here's a few ways to get in touch with me.
Yes, for those of you who want to ask Dr. Klotzbach a question, go ahead and use the chat option on your screens and just type in your question. And then Phil said we got about 10 minutes until our next presentation. So please take advantage of the time you have with Phil and see if you can answer any questions that you may have regarding our outlook and some of the interesting stuff that he's been working on, interesting research.
Very quiet group this morning. No questions. I'm sure there's questions out there. Let's see. What can we talk about here? Yeah, I think so. One of the reasons why I started doing the wind pressure stuff was I grew up on the East Coast. I grew up in Massachusetts, and so a lot of these storms, as they move up the coast, the categories come down, but they still can be very, very impactful. So that's one of the things that I do is whenever you see the hurricane hunter planes flying into a storm, the first thing I look at is, you know, is the pressure going down? Because if the pressure is going down, generally you have one of two things happening. You either, one, the winds are coming up, or the storm is getting larger, neither of which is good. Obviously, a larger storm means obviously a much larger area to be impacted. Also, the storm surge threat also increases with those kinds of storms. And obviously, if the pressure is, and obviously a larger storm is more damaging than a smaller storm for the same overall wind intensity. So I think that's a couple of things to look at. I think also too with a lower pressure storm for the same size, you won't necessarily know how much rain the storm is going to bring, because obviously that's governed by how fast the storm is moving, if there's mountainous terrain. But I think overall, in terms of the rainfall footprint, a larger storm is going to dump rain over a larger area, just because obviously the storm is larger and has an overall larger cloud shield.
Okay, one question we had from audience is, are you able to export data tables from form website into ESRI? Esri.
Okay, so export, I mean, if you have like the historical hurricane tracks and all that information, there's a website called IBTracks, which is basically a global tropical cyclone repository, and all of they have a bunch of GIS data, so a bunch of shapefiles that you could certainly export into ESRI products, Google Earth, any of those types of imagery. So I personally don't make GIS shapefiles, but certainly all the data from National Hurricane Center is in the International Best Track, and that IBTracks archive has all a bunch of GIS data that you can use. There's also a really nice visualization tool that NOAA has for historical hurricane tracks. And so that historical hurricane tracks website, you can basically go in and search for a particular town and then see how many hurricanes made landfall near there. We are actually starting to develop some new real-time mapping capabilities on our website as well. They won't be available June 4th, but that's hopefully something we're going to be unveiling in the next few weeks as well. So stay tuned for that.
Okay, another question is, now this is one that's been mentioned by a number of the attendees is, can we get a copy of the slides? We are recording this session. So if you go back to the National Hurricane Conference website, you'll be able to link on to this particular session and see the slides. I hope that answers questions that some of you had regarding that. Another question we got, is there a plan to integrate pressures into the HWS and forecasts?
Well, we'll see. This is just, let's see. Oh yeah, this is just research that we've done that's going to be published. It should be published this month in the Bulletin of the AMS. Where it goes in terms of operational implementation remains to be seen. But I think at least from a general public, in terms of a messaging perspective, I think people that are, besides the Saffir-Simpson hurricane wind scale pressure, the nice thing with pressure is it's something we measure in real time. So you can know basically just from looking at when the aircraft is flying in, you can know from there what the pressure is at any particular time. And it's more akin to that integrated kinetic energy and some of those more integrated metrics that are used. But the nice thing with pressure is you have the number pretty much instantaneously when the plane is flying through the storm, as opposed to waiting for models and everything else to give you the integrated kinetic energy. Unfortunately, I don't think that's available with more of a delay.
Another question we got is, are you encouraged that more seasonal forecasts are being produced, or does it just make the field noisier?
Well, I think it's great. I mean, Dr. Gray used to always say that imitation is the best form of flattery, but no, I mean, I think it's great. I mean, I think the more people that are doing this, I mean, seasonal forecasting certainly isn't perfect. There's a lot of avenues for improvement. There's a lot of different techniques that are being done. I mean, we've started doing some more incorporating climate models, which when Bill Gray started doing this wouldn't have been possible because climate models were in their infancy and were just plain lousy. Now their skills improved, so we're using the information that we can get from these dynamical climate models. There's basically, I know it's kind of a buzzword, but there's a lot of like machine learning work that's going on. So trying to use different techniques to improve the forecast. I mean, there's always going to be uncertainty with the seasonal forecast. I mean, you're trying to forecast the overall hurricane season months in advance. But I think there are avenues that we can improve the forecast of these storms. And obviously, kind of the holy grail and something that we're all looking at is more how much of a track piece can you incorporate to these as well. Certainly you can't say how storms are going to track, months in advance, but if you even had a month where you could have a little bit of predictive skill saying, okay, the next month storms are more likely to recurve or move straight moving, that I think that having that kind of information, maybe even a few weeks to a month in advance, would certainly be very useful. So that's stuff that we're currently working on as well.
Okay, another question, is it better for a populated area to be impacted directly by landfall, or is it better to be just to the left or right? I'm assuming of landfall.
Well, generally the strongest winds are just to the right of where the storm makes landfall, but obviously, if a storm makes direct landfall over you, that's generally a very, very bad place. I mean, obviously, if the storm is moving and you're on the left side of the storm and you're, say, 50, 100 miles away, your impacts most likely are going to be less, with dependence on, exactly if there happens to be mountainous terrain to the left of the track, you could have seen more flooding or something, but overall, you'd rather be on the left side of the hurricane storm track than the right side, all else being equal.
Okay, another question here is, are the 2020 hurricane impact probabilities available for Puerto Rico and the U.S. Virgin Islands?
Yes, we have probabilities for every island in the Caribbean, as well as the probabilities for the United States. Those should be available on that website. And ideally, hopefully, they're going to be updated on June the 4th as well with our new forecast numbers. But those numbers shouldn't be too different from what would be currently on there.
Okay. Can you tell us what type of predictions you're working on for the current TD3?
Well, we don't do individual storm forecasts. That's the National Hurricane Center's job, and I do a really, really good job with it. I'm glad we don't have to do the individual storm forecast. Basically, so what I do when there's individual storms is I post a lot of content on Twitter that's basically trying to put these storms in historical context. So, for example, if this storm gets named in the next few hours, it will be the earliest third Atlantic named storm formation on record. So I try to put these storms kind of in historical context. And, when there's major storms like Dorian and Irma, I'll try to say, okay, how they compare with other historical storms. Are they the strongest one to hit this area, the second strongest, the fifth strongest, trying to kind of put these storms in overall perspective, but the Hurricane Center does an excellent job of forecasting individual storms, and I certainly don't do anything with that.
Okay, got time for maybe one more question, and I apologize to those who submitted questions that I didn't get to. In the graphs of wind, then pressure from storm, Irma was a point in the first graph, but not in the graph of pressure. Where does Irma fit into the graph?
Irma should be on the graph of pressure. I'll go back after this and see if there was an issue with my plotting. I put together some plots last night, and but I'll take a look. But it should be there. Hang on one second. Let me just step back real quick and see if it's on there.
What's up?
Let's see. Oh, yeah, where did it go? That's very weird. I will correct that. Thank you very much for noticing that. I apologize.
All right. Thank you all for your questions. I'm sorry that I wasn't able to get to all of them in time. We're going to be going to our next speaker. So Phil, thank you so much for joining us. I'm assuming you're in California right now, or are you in Colorado?
No, I'm in California, so it's bright and early here.
Okay, well, thank you so much for coming up. And let me go ahead and give me back the screen.
All right, you should have control.
Okay, thank you, sir. Our next speaker is Ken Graham, who is the current director of the National Hurricane Center in Miami, Florida. Ken began his career in NOAA in 1994 as an intern forecaster at the National Weather Service in New Orleans. His career took him to the agency's Southern Region headquarters in Fort Worth, Texas, as Marine and Program Manager during National Weather Service modernization in the early 1990s. He became the meteorologist in charge at the National Weather Service Forecast Office in Corpus Christi, Texas, and Birmingham, Alabama. He has served as System Operations Southern Region headquarters, where he won a bronze medal for leading a team to make critical repairs in New Orleans following Hurricane Katrina. After moving to Washington, D.C. to be Chief of Meteorological Services, where he worked closely with partners to improve services and brief congressional committees, he then served as the meteorologist in charge at the National Weather Service office in New Orleans, Baton Rouge office, before coming to the Hurricane Center. Ken has extensive experience working directly with emergency managers during numerous high-impact events, including nearly 2 decades along the United States coast. He has deployed to emergency operations centers, provided impact-based decision support briefings for emergency managers and elected officials, and delivered numerous training sessions and exercises related to tropical weather. He received his Bachelor of Atmospheric Science degree at the University of Arizona and earned a Master's of Science degree in Geosciences from Mississippi State University. Good morning, Ken. Thanks for joining us. I know you've got a kind of a busy hurricane season going out there, but what are your thoughts about this particular hurricane season as well?
Well, it looks like, all indicators, you just heard Phil, and every indicator we have seems to be going to be a busy season. So that's what we're looking at, and off to a quick start, right? Already looking at some busyness already, and watching the Gulf real close. So I'm going to show my screen, and hopefully this will come up here. Can everybody see my screen?
Yeah, go ahead and start in slideshow mode.
Okay, sounds good. How was that?
Perfect.
Okay, well, great. I mean, I just want to say thanks, Phil. Great presentation, and appreciate the invitation to talk to everybody today. Thanks for joining, and wow, thank you all for putting this together virtually. What a big switch, but you know what? We're doing the best we can with the information. So let me share a few things on my mind here this hurricane season. I was trying to think about what I was going to say this year, and then it hit me. I don't know what happened, but I started realizing, 27 years of doing this, there's a lot of things over the years kind of go as lessons. So I wanted to share some of those with you today, and should be able to have some good discussion about it. First of all, I wanted to share the outlook. You just heard the whole seasonal outlook from Phil, and just the NOAA outlook here, same thing. I mean, we're looking at an active season with the named storms, the hurricanes, and the major hurricanes. So we're looking at an active season from about any indicator that we're looking at. And 2020 getting off to quite a start with Arthur and Bertha taken care of, and we're watching the system in the Gulf real closely for what that's going to do this week. So stay tuned for more information on that. But a couple changes. I did want to start off with a couple changes for 2020. We've got two new things that I really wanted to share with you today. The first one is it's an experimental graphic. I hope this is useful to you all. We're definitely going to be open to comments during the season and some feedback. This is an experimental peak storm surge forecast graphic, and it really what it does is it shows some hot spots, so to speak, and some of the peak values, the max values that we're looking at. So you can quickly get a big picture, a high level picture of some areas that we're concerned with for storm surge. And then from there, you can start digging into the inundation mapping, getting into the probabilistic surge, more information there. But this is a quick way that can be shared on social media, can be shared in briefings, just a quick way to be able to look at some areas of interest, so to speak. So that's one new thing. The other one is everybody's going to notice a new dot on the forecast map. Here's the cone. We've added a 60-hour forecast point, and this is important. It's not so much just for the intensity and the location for us, but it's also going into the storm surge forecast, for probabilistic surge and looking at the tropical cyclone wind speed probabilities, we need to know the size of the storm. So we had this location. It's going to really help us out with the storm surge forecasts and looking at those probabilities, because we'll have the structure, the size of the actual wind field. So that's going to really help us out. So you're going to see that extra dot on the map this season. So those are the two highlights that we have new that I think people will be interested in. So I want to go into these lessons. It's interesting to reflect over the years and think about the different things that all the different storms, and they're all different. We talk about every hurricane season's different, every storm is different, every situation is different. But I did want to share this. This is an important one for me because it's a little cliche, but there's no such thing as a fish storm. Here at the National Hurricane Center, we cover from the African coast, the European coast, all the way to 140 west near Hawaii. So if you think about that large area, we're responsible for the hurricane forecast, tropical cyclone forecast for that whole area, and also coordinating with all the countries located in that area as well. So this is a typical one. You can see it on the loop here. You can watch this go in. Look at all the watches and warnings from all these different countries. That they issue their watches and warnings, but we put out the actual hurricane forecast and the track forecast and the cone. So you can see all the coordination. Those are all phone calls. Those are all coordination calls that we have to do to talk to everybody to coordinate that forecast. So no such thing as a fish storm. So that's point one. But the other part of it is, this is an interesting question that we pose. And behind Dorian, we know, very large impact in the Bahamas, very devastating, including the loss of life. But look at the second one. What was the second one behind Dorian? And the answer actually surprises a lot of people. It was Lorenzo. So let's examine that for a second. Look at Lorenzo, how far away that is from the US coast. But a few things happened associated with Lorenzo. 19 direct fatalities in Hurricane Lorenzo, 11 of those offshore due to the sinking of the Bourbon Road. 3 crewmen were rescued. And it's an interesting note associated with this, that the Tropical Analysis Forecast Branch here at the National Hurricane Center was providing spot forecasts, providing latitude, longitude, marine forecasts for this search and rescue effort. And also the hurricane hunters from NOAA sent the P3, went to go help out, search and rescue operations as well. So NOAA was helping out with the search and rescue associated with this. But there's one more point I want to make. Also, 8 rip current deaths in the United States, from Florida all the way up to Rhode Island. So no fish storm. Look how far away this track is. Look how far away the storm is, but still sending swells, dangerous waves, dangerous swells toward the U.S. and causing some rip current fatalities. So just a point that I wanted to make. For us, all storms are busy. We watch all of them, and they can definitely have some impacts on the U.S. coast, but definitely for our international partners. So lesson 2, I wanted to talk about this one. Be careful looking at your favorite model, and I have a few points to make with this. And there's always a lot of quotes associated with this one. I get them because I'm getting text messages as we speak about the system in the Gulf. It says, oh yes, all those lines miss us, we're good. These are quotes. Oh no, one of those lines hits us in 10 days, we're in trouble, type of thing. And this model was best last time. These are typical quotes that we see. So I wanted to examine that a little bit. And every year I do share you know, just the improvements, the leaps. I mean, just an incredible scientific success when it comes to the track forecasting improvements over the decades. You can see through the 60s, the 70s, 80s, all the way through now the 2000s. You know, the lower the line there, the less track error that we have in nautical miles. Just an incredible improvement in track forecasting. So that continues. Every year we do make improvements. There's every storm's a little different. Some are tougher than others, but for the most part, overall, we're making improvements. So we did an analysis, and I put this together 2017 through 2019, because you can go back in time, and this was definitely true, but it was interesting to look at modern times. The NAC forecast still beats the models. So the technique that we have looking at one line, we don't do that. So any individual model, we're looking at ensembles. We're looking at ensembles from different models, blending those together, putting those together, forecast experience, putting everything together. So if you look at the actual skill forecast, we're still better than the models. Why does this matter? Well, the track forecast, we spent a lot of time improving that because this is why it matters. If you look at this would be the cone at 3 days, the NAC average track error in 1990. Look at that. So I mean, if you think about in a storm with that kind of cone out 3 days, I mean, large evacuations, huge evacuations, a lot of people getting away from this because of the track error at the time. This next one, that's the track error at 3 days today. What a difference. And that makes a huge difference, because you think about those that evacuate, that we really want people to evacuate if they really need to evacuate. We don't want people evacuating if they don't have to, because there's a lot of dangers associated with that as well. So what a difference. I mean, that has made such a difference over the years. So lesson 3, it's all about the impacts. This is one I cover every year, and we try to look at some slides here that really drive this point home. This is a good one. I mean, the one on the left, you can see the cone, and you can see the size of the storm. Just by default, there's impacts outside that cone. And remember, the cone, for everybody listening, that is a cone of error. That's based on our average error in track over the last 5 years. The cone is built based on that. So the better we do, the smaller the cone. Smaller the cone, more impacts outside the cone. So we have to keep having this conversation to make sure that we remind everybody of this, because it's real important. The one on the right, we added the wind field, trying to show that there's impacts outside the cone. So you can see the cone there, and the orange blob that you see on the screen, that's actually the wind field. Look how large that is, considering what you have with the actual cone itself. So you think about it. I shared this before. I want to share it again. And by the way, it's not just the wind, it's the storm surge, it's the rain bands with the tornadoes, it's the rainfall itself. All that often occurs outside the cone. So let's look at this. We really think about, it's about the impact. Since 2010, Category 1 hurricanes have produced 175 direct fatalities and $105 billion worth of damage. So it's about the impacts. It's not about the category. It's not about whether it's named or not. We've seen many tropical storms that are moving slow, and they're large, that could produce storm surge, and they could produce copious amounts of rainfall. So there's another example right there that we always think about. No such thing as just a tropical storm, no such thing as just a Cat 1, because look at those impacts. So we spend so much time on that, and we will continue to be able to do that. Lesson 4, everybody. This one is always really important to me, and we've got some projects going on associated with this as well. Social science matters. So you could put out a perfect forecast if it's not actionable and understood, and then that leads to failure. And that's why we spend so much time also in the social science. This map here, this is the most likely time of arrival of tropical storm force winds, and had social science go into that. The storm surge products had social science go into it. So it helps, because the colors, the lines, how the graphic looks, it's not just about the physical science, which we work on all the time, but it's also the social science. Is it understood? Is it easy to read? So we spend so much time as well. And actually I told you we had some projects going on. We have 9 social science projects going on as we speak, to look at our website, to look at the cone, to look at about everything that we do to ensure that we're doing the best job we can, making it simple, easy to understand, and really convey the message. So we spend a significant amount of time on that. And everybody probably has seen our key messages. You can see them now, even associated with the system in the Gulf. The key message is we agonize over every word. I mean, 2 to 3 people read it, they look over each other's, they try to help, really try to key in on every single one of those words. So because words matter, and that's part of the message, and we spend lots of time on that. There's just some other examples of physical science and social science coming together with the storm surge products. All of these also vetted with social science, and it was that information that led to the colors, the lines, everything associated with this, and the fact that when you look at inundation, it's water up your pant leg instead of any sort of conversion that might have to occur. So that's something else that was some feedback that we had. And I remind everybody, I do like to share some of these every single year because it's huge. And you think about it, your perception of your risk is generally based on your past experience. And every storm is different, every season is different. And if you think about it, these are quotes that we hear often. A lot of surveys over the years, meeting people. I didn't know it was going to be this bad. I'll never stay again. And then you drive 4 or 5 miles down the road and said, well, that wasn't that bad. I'll never leave again. Little wiggles matter. Little wiggles really matter. 30, 40 miles difference in a tropical system, in a hurricane, can mean the difference between 1 or 2 foot of storm surge and 10 foot of storm surge. 30, 40 miles difference could put you in a rain band that you get 12 inches of rain, 15 inches of rain in tornadoes. A little bit of a difference, you're out of that rain band, you may get a couple inches of rain. Little wiggles matter, little changes matter, and that's something that we have to definitely all communicate together to everybody. These aren't false alarms. It's just the nature of the actual storm itself and the structure, especially with these large storms, when you can get those rain bands hundreds of miles away from the center. So it's interesting to look at. The last one here is an interesting one called anchoring. It's something that it's one of the projects that we have with our social science projects, one of the 9, and it's when you look at a storm, what it's doing 3 or 4 days ago, and then that's what you remember, and that's the information that carries you through the storm, even though things change, they evolve. We see these storms that rapidly intensify, things change. So not anchoring on the information is something we're looking at as well in some of our projects. Okay, lesson 5, halfway through the lessons here. Intensity forecast is still difficult. We're making improvements. I mean, that's if you think about it, you look at those dashed lines, they're all going downward. That's what we like to see. So we are making improvements, but it's much slower than the actual track forecast improvements that we've seen. And you do see some spikes up. There's just still storms that don't behave, and you see some spikes up even in recent times. So if you look at it, and I think this stat's interesting, the second largest annual error at 5 days, mostly because of Dorian, and I can show you why here in a little bit. So intensity is still a very difficult forecast, but if you look at it, still making some progress, definitely getting better with it, but at the same time, we have a ways to go and a lot to learn associated with the intensity. A lot of projects going on, including a look at the heat content of the atmosphere, using gliders to be able to get profiles of the ocean. Are we stirring up cold water? Are we stirring up warm water? So there's a lot of research going into this problem. So we look forward to progress with time. Lesson 6 is related to that, related to the intensity. And it's one I wanted to share this year. There's so much potential error in the genesis phase. In other words, when they're starting up right now, even with the system in the Gulf of Mexico, once they're starting up, there's a lot of error associated with that period of time. And and if you look at this one, it's a good example. When you look at the Dorian is a good example of that. I just wanted to share some of this here. And if you think about it, where Dorian formed was going to make a big difference in the actual outcome. Now, early on, when the hurricane hunters were out there in Dorian, when it was just forming, they found 3 centers, 3 different centers at the time. And so the models have a tough time. Which one's going to be the ultimate center? Which one's going to be the dominant center? And that can have a big influence downstream, especially in the extended forecast. So I wanted to share this example because I think it illustrates. I could go back in time and find lots of them, but it's nice to find the most recent one. There were 3 scenarios in Dorian with those centers. One of them was you're on the left side, the actual left side of the cone. So, you would have a large impact over Hispaniola, and there's mountains, there's terrain, a lot of elevation in Hispaniola, probably disrupted or dissipated Dorian altogether. Probably might not have survived going over Hispaniola, and that would have meant, probably maybe some recovery, possibly not, but rain for Cuba, rain for Florida, probably a rain event but a faster solution in this case. Scenario 2, right up the middle, some influence from Hispaniola, also Puerto Rico, where you'd have some disruption in the storm, a bigger impact to Puerto Rico with rainfall and wind, but there'd be some weakening with time, but some time for re-strengthening, probably a stronger storm, probably still a hurricane, but a faster solution, which meant you might have missed that the chance to stall. So it might have been going faster, probably a bigger impact for Florida at that time. And at one point, the center jumped over to the right-hand side, and that ultimately became the solution. And if you look at it here, that's what happened. Missing land, lots of warm water, and a slower track. So in other words, more time over that water to intensify up to the Category 5 strength. And because slower, the steering currents moved out, and that allowed for that stall over the Bahamas and a devastating event that Dorian was. So look at all those solutions. Any one of those, and in the earliest stages could have happened. And that's why we remind people, in the earliest phase, the genesis phase, lots of room for error. That's why we say things like, got to have your hurricane plan ready. And that's what we're doing for the system in the Gulf, because there's a wide variety of potential solutions. In the end, the actual track forecast was good. And you can see we always share our basically our stats, where we do well and where we struggle. Intensity was incredibly difficult for us because of the interaction with land and the eventual track. But the other part of it is the track itself was a good forecast. And we've come so far. I wanted to just kind of compare this. This kind of brings a couple points home. The 3-day track error back for Hurricane Floyd in 1999 was 236 nautical miles, if you think about it. And this caused one of the largest evacuations in U.S. history at the time. 2.6 million people evacuated from 5 states. Florida, all of Florida heading out, the Carolinas, Georgia, just a big evacuation. So look at the track for Floyd there, and look at the track for Dorian. A couple things that you notice. One, similar track, but the other part is they're concentrated together, which is another indicator. Those forecasts were more accurate and more consistent. It's another way to put it. But the average track error now, looking at it, was look at 35 nautical miles, which is interesting. And you think about it, this is preliminary data, but as many as 3 million did not have to evacuate because of Dorian. That's coming a long way. So I wanted to share that. Getting into the next one, I'm going to do it again because I think this is important. I'm starting to share this every year, but when you close your eyes, what do you think of when you think of a hurricane? And it's, most people still, unless you've seen these presentations, are still, thinking of the wind. But the reality is, it's water what kills. And then this is lesson 7 that I wanted to share. And in the final 3 lessons that I wanted to share today, water is about 90% of the direct fatalities in these tropical systems, and it's so important to keep talking about it. We have to keep repeating this and really spreading the word about it, because you think about these values, 90% is incredible. Half of those historically in storm surge. I think we're making a difference. We have the storm surge watch and warning, got the inundation mapping. We are seeing that trend lower, but at the same time, we still see the issues associated with inland rain. 27% of the fatalities caused by inland rain, and that's why we constantly talk about, these tropical systems is not just coastal. We evacuate for the storm surge right along the coastal evacuation zones, but inland along rivers where you can get these slow systems produce an incredible amount of rainfall. That's where the dangers are, and trying to communicate what could happen inland, which is interesting. So really narrowing that down a little bit more, we looked at 2016 to 2018, 83% of the fatalities from those tropical systems was water related. Interesting enough, 4% storm surge related. Maybe we're making a difference. We'll see what's going to happen long term, but it's inland flooding. And here's the stat that really drives this home a little bit. So the 83% inland flooding, about a little more than half of those are in automobiles. So the whole turnaround, don't drown campaign needs to continue. We need to keep talking about the issues that we have with folks driving water into the water, or not being able to see the road and going into canals. There's a lot of reasons for this, but we still need to keep the outreach. We need to keep the message going about the dangers of water. Lesson 8, last few of them here, everybody. It isn't over till it's over, and it's there's a thought that, once the storm's passed me, there's such a concentration sometime on that center. Once it's passed, well, I'm safe now, and that's not the case. And you still have some of the, some areas actually get their highest storm surge after the passage of the center, where the winds change directions and actually go on shore in some areas. You see that in many areas along the coastline, depending on the shape. So some of the dangers could be afterwards. I've seen some of the strongest rain bands occur on the backside as well. So every one of these are different. It's not over till it's over. And you look at the indirect fatalities associated with the longer term impacts. And one of the largest cause of those fatalities historically is cardiac arrest. It's health issues. It's issues associated with that, and a lot of that could occur during and after the storm as well, indirectly. This is a brand new stat I did want to share with everybody. Looking exactly at the same data, Ed Rappaport put this together and really was looking at the vulnerable population part of it. And we're going to continue to look at some of this data. But one thing that stood out, I wanted to share when it comes to the vulnerable population, the data shows that there's 8 times more victims age 60 as under 21 years old. So that's something to think about. It's one of the days that we have on the Hurricane Awareness Week that talks about help the neighbor, help your neighbor, and that sort of thing. We got to take care of the vulnerable population because they tend to be the higher risk in some of these storms. Lesson 9, storms don't care about your timeline. I've been doing this so many years, and I've seen this so many times where we'd love to get 10 days notice. We'd love to see them come off of Africa and like a Florence and come all the way across the Atlantic, and there's time to prepare, there's time to get ready. We have all the time in the world to message all the impacts and everything that could happen here, but they're not always like that. It's just the nature of meteorology that we don't always have it. Michael only gave us 3 to 4 days from the time you look at this system to the time that starts to develop. And Michael was another one that had multiple centers, and any different any one of different outcomes could have occurred, kind of like the DORIAN situation when it came to Michael as well. And it's something to think about. So I encourage everybody listening, when we work our plans, we have our family plan or business plan or official plan, whatever it may be, and usually we work them. I've done a lot of partnerships with exercises and that sort of thing. You work a 7-day plan, a 10-day plan, but the reality is you might have to accelerate it to 3 days or 4 days. So when you exercise your plans, try to shrink up that timeline, because that can definitely happen. And another reason we always tell everybody, you got to prepare early, because sometimes this ramps up really, really quick. So that's another one. Another example is just looking at where were the nation's most powerful hurricanes 3 days before landfall. And I wanted to share this again this year because there were only 4 Cat 5 landfalls in the continental United States. There was the Labor Day storm, Andrew, Camille, and Michael. Every one of them were tropical storms just 3 days prior. So they're rapid intensification situations. Things can ramp up really quick, even if you see them. Even if you see them coming for a long time, they can still hit a situation where all the conditions are so favorable that they rapidly intensify and they change what we need to do. So all of them rapidly intensifying, and that goes back to being ready. And the last lesson, and I could probably think of more looking back over the years, but these are the ones I kind of wanted to share with everybody. Message, if you're messaging, message in a lot of ways. I keep thinking about this. My kids get information differently than I do. I get information differently than my mom. Everybody gets different, information from different places, and I think it's important that we realize that and communicate in many different ways, different places, but together. I think that's so important. All the studies I've seen is we have a consistent message. It's more actionable to the public. So it's just amazing how we all come together. Our amazing partners in the media, amazing partners in emergency management. I just respect all of them so much in this partnership. We all come together for a message, a consistent message. Then we put it into a lot of different places, and we can reach a lot of people and save a lot of lives. The key messages, I did focus on that already. The key messages you can see on this graphic in the upper left, we agonize, we really do, over every word. We re-edit, we think about it, we send drafts to each other on text message and try to come up with the wording. It's important. So we recognize those key messages are really important. So I have to discipline myself all the time and stop, because I get pretty passionate about this topic, as you all know that know me. I just wanted to thank everybody, thank the organizers of this conference, all the presenters. Thank you for the partnership. Busy season, we're ready for it here at the Hurricane Center. We're going to be here issuing watches and warnings, just like we always do during the season. So we're going to stay healthy here so we can do what we need to do to save lives and perform our mission. So thank you all for this opportunity.
Thank you. Candy, can you give me back the screen, please?
I will do that when I figure out how to.
Go up that change for some. There you go. Thank you, sir.
There we go.
Appreciate it. Now I'd like to welcome to the screen Pete Gaynor, who was confirmed by the Senate on January 14th of this year as the administrator of the Federal Emergency Management Agency. He has more than 11 years of experience in emergency management. And prior to coming to FEMA, he served as the director of Rhode Island's Emergency Management Agency from 2015, where he advised the governor on emergency management policy and served as a principal liaison between FEMA and the local emergency management offices throughout Rhode Island. Prior to his appointment, he served as the director of the Providence Emergency Management Agency and Office of Homeland Security from March 2008 through December 2014. During his tenure, both at the state and local level in Rhode Island, he oversaw multiple response and recovery operations, as well as managing numerous federal declared disasters. Prior to his experience as an emergency manager, he served for 26 years as an enlisted Marine and an infantry officer in the United States Marine Corps. Administrator Gaynor received his bachelor's degree in history from Rhode Island College and a master's degree in national security and strategic studies from the Naval War College in Newport, Rhode Island. He is also a recent graduate from the Center for Homeland Defense and Security Executive Leaders Program. Administrator Gaynor, thank you so much for joining us today. I know you've been extremely busy with all the events that you've been dealing with.
Thanks, David. Appreciate the intro, and good morning, everyone, on this virtual hurricane conference. Thanks, John Wilson, for ensuring that the conference goes on and we have this opportunity. I also want to thank Phil for sharing the forecast and the outlook for the hurricane season ahead, as well as Ken Graham for his continued excellent work at the National Hurricane Center. I hope to see you, Ken, here shortly. So thank you, everyone involved in planning this year's conference, and acknowledge the additional work that went into turning this engagement into a virtual interactive conference. When we look back to when the decision was made to cancel this year's conference, I know that it was not made lightly, but that decision, along with so many other decisions that have been made across the whole of America response to the corona pandemic, is what has helped our nation and our communities get to where we are today. We reduced the spread, we flattened the curve, we protected the most vulnerable. That's why I also want to thank all of you who have joined today, not just for being here, but for your efforts across the country to help our nation respond to and recover from this pandemic. Each year, the National Hurricane Conference provides an opportunity for emergency managers and partners to come together to share strategies and best practices that protect people and property in the months ahead. During normal times, we would raise our vigilance to another level based on the forecast we just heard from the National Weather Service. It goes without saying that 2020 has not been a normal year for our emergency management community, and even without the forecast for an above average active hurricane season. For months, we have engaged in the ongoing COVID-19 response and recovery, which will continue to increase the level of difficulty for all planning and operations in the months ahead. For the first time in United States history, there are 57 concurrent major disaster declarations which represent every single state, 5 territories, the Seminole Triad of Florida, and the District of Columbia. From the islands across 2 oceans to the major metropolitan cities of America, the scale of this historic event has forced FEMA to adapt its response practices and workforce posture in order to both respond to COVID-19 and simultaneously maintain mission readiness for more common disasters such as hurricanes, earthquakes, floods, and wildfires. Regardless of the challenges that FEMA continues to face, our mission remains constant, helping people before, during, and after disasters. Even with COVID-19, it has certainly changed our lives, and the overarching blueprint, which we will accomplish this mission, again, remains unchanged. Disaster response remains most effective when it's federally supported, state managed, and locally executed. Amidst these unprecedented times, the nation is counting on us to accomplish our mission, and we will do so in accordance with our core values of compassion, fairness, integrity, and respect. Each of you as leaders represent the example that our communities need going forward. COVID-19 will not be the last pandemic the American people will face. It is therefore imperative that we continue to prepare at all levels of government, within our communities and across the public-private sectors by learning from what we could be a first wave of this virus. Furthermore, building a culture of preparedness through a whole of America response could be a more important component of our ability to respond effectively to other disasters such as hurricanes or wildfires during this sustained pandemic response. Operating in overlapping disaster environments will create new intricacies within already complex mission requirements. For example, there will be a new need to evacuate strategic national assets such as ventilators and key pharmaceuticals. Evacuating people within the COVID-19 environment will represent an even greater challenge and will likely necessitate widespread availability of non-congregate sheltering. In trying to get Americans out of harm's way, we must avoid putting them in harm's way via crowded public shelters. Furthermore, COVID-19 may slow down state, territorial, and tribal abilities to conduct damage assessments to disasters such as flooding, severe storms, and hurricanes. Response to other disasters, in turn, can slow down the ability of officials to collect crucial information about COVID-19 cases and stymie their ability to share critical data needed to combat it. Consequently, there is a potential for a compounded effect that will result in a larger emergency than each disaster would be on its own. These are some of the considerations FEMA accounts for as it pivots to prepare for a high likelihood of an active hurricane and wildfire seasons. We know that these considerations are shared by our federal, state, local, and tribal and territorial partners, and we will work together to make sure our plans and approaches will be effective for operating in this COVID-19 environment. A few weeks ago, FEMA published operational guidance to address the complications associated with this pandemic. Using best practices and guidance from the Department of Health and Human Services, the Centers of Disease Control and Prevention, medical practitioners, and emergency managers to develop updated policies and procedures. The COVID-19 pandemic operational guidance for the 2020 hurricane season describes anticipated challenges to and planning for disaster operations posed by COVID-19, as well as actions emergency managers and public officials can take to prepare for those challenges. By creating a shared understanding of expectations among FEMA and our SLTT partners, the nation will be better positioned to achieve successful operations and outcomes in disaster response and recovery efforts. While this document focuses on hurricane season preparedness, most planning considerations can be applied to any disaster operation in COVID-19 environment, to include no-notice incidents, spring flooding, wildfires, and typhoon response. This week, FEMA will deliver several webinars on actionable guidance to support our partners in their planning. We will be your partners to help develop and create response preparedness plans to serve your communities and protect your local first responders and emergency workers, while we also protect the health and safety of our disaster survivors. This guidance is one way that FEMA actively prepares its workforce and promotes readiness with state, local, tribal, and territorial partners to be prepared in a continued COVID-19 environment. Expect to see the use of more virtual or no contact methods to improve our response before, during, and after disaster events. And let me just go through a couple of those efforts that we plan to use this season. Working with our SLTT partners to support sheltering planning efforts that are locally implemented, state managed, and federally supported to ensure the safety and security for all. For example, following recent tornadoes in the southeast, we use hotels to ensure survivor safety and respect social distancing guidelines. We're establishing virtual operations to improve customer service. We used the challenge presented by COVID-19 to rethink how we service communities, and we'll use more virtual environments in joint field offices and national and regional coordination centers. We're going to be conducting virtual inspections for FEMA individual assistance, as well as the National Flood Insurance Program claims, by using pictures and video streaming from impacted survivor homes whenever possible. When completing preliminary damage assessments for public assistance, we're going to use remote windshield surveys from a vehicle or virtually using desktop assessments. We're going to coordinate disaster survivor assistance with our SLT partners to help FEMA determine the use of disaster recovery centers or survivor assistance teams in accordance with impacted areas to reduce door-to-door interactions. We may also use online and phone registration and virtual assessments to ensure program delivery. We're publishing guidance documents and conducting training to include dissemination of guidance and checklists for our SLTT partners with recommendations on how to adjust planning efforts in a COVID-19 environment. FEMA leads the whole of America response to COVID-19 with many of you, our partners in the state, local, tribal, and territories. I hope that we have been able to develop clear lines of communication and build trust through these partnerships. While we probe parts of the disaster response playbook we never wanted to use, this experience has been informative and has given us an opportunity to apply different ways of thinking to our traditional disaster response methods. By building this partnership between federal, state, and local governments, our unified response has strengthened the foundation of emergency response systems and will pay huge dividends this year and for many, many years to come. With that in mind, we will have to lean forward and prepare to take on challenges that will come to our nation and our communities during this hurricane season. This will not be an easy task, and many of you know this firsthand. Whether your experience comes from rescuing those in harm's way from storm surge during direct hits along coastal regions, or cleaning up the impact of heavy rains and strong winds further inland after landfall, we know that these storms demand a robust and coordinated readiness and response effort. So let me just describe how FEMA is working to support all of you. That history with disaster response informed many of our processes and guided our path as we examined our operations. After the hurricane and wildfire seasons of 2017, FEMA reviewed the National Response Framework to incorporate the lessons we have learned. And here are some of our conclusions. First, we determined that FEMA needed to be stronger in building the culture of preparedness in our country. To that end, we have established better cross-sector operations with the help of the Cyber and Infrastructure Security Agency, or CISA, to coordinate with more than 16 federal agencies and departments to improve planning and operations. In 2019, we awarded $2.4 billion through approximately 2,800 preparedness grants to improve the nation's readiness in preventing, protecting against, responding to, recovering from, and mitigating terrorist attacks, major disasters, and other emergencies. To further prepare the nation for catastrophic disasters, FEMA released the Community Lifelines Implementation Toolkit 2.0 and the Incident Stabilization Guide, which provide updated information and resources to better understand and implement community lifelines throughout the emergency management community. Last year, we approved over 200 additional local, state, and tribal agencies to distribute emergency alerts over our Integrated Public Alert and Warning System, or IPAWS, bringing the total number of alerting authorities to 1,461. FEMA has also increased the number of FEMA integration teams, or FIT teams, to assist our state and tribal partners to prepare for and respond to disasters, with about 113 staff embedded in 38 states full-time. We acknowledge that FEMA's structure has become complex over its 41 years of existence. We have worked hard through 2019 and into this year to successfully implement over 75% of the provisions outlined in the Disaster Recovery Reform Act of 2018. These reforms acknowledge a shared responsibility for disaster preparedness, mitigation, response, and recovery at all levels of government, while streamlining the delivery of disaster recovery programs. One of the most frequently questions I get asked about at FEMA is the concern about how our agency respond to multiple disasters. I've already outlined some of the adjustments we're making, but I also want to share that with 3,000 employees responding to COVID-19, we have a team of over 20,000 emergency managers across the country and have the full backing of the federal government. Even more importantly, we are part of a nationwide team of emergency managers that together have evolved our nation's emergency management approach. By advancing shared responsibility for emergency management, building a ready FEMA that is able to respond rapidly when America calls, and strengthening our core management functions, FEMA will continue its commitment to this strategic plan and strengthen our ability to help people before, during, and after disasters. A little bit about building community resilience. And this is really the final piece of the puzzle for preparedness that reaches beyond the work we do at FEMA and the work you do in the communities from rural areas to the largest cities. And that is inviting the public to accept their role in emergency management through preparedness. We are seeing the effect of the pandemic is having on our psyches of our friends and neighbors. Imagine adding the stress of a catastrophic hurricane to that, and I can predict that human reactions will be heightened, complicating your operations during these difficult periods. One of these reactions can emerge is playing out right now in the civil unrest that has happened across the nation related to the death of George Floyd. This will become one of our greatest challenges during a time when millions of Americans are struggling to regain their footing as shutdowns and disruptions have added uncertainty to day-to-day life. Community resilience will be a crucial factor as all of us try to grasp a little bit of normality, and we will need to have strong local leaders to help build resilience and help your friends and neighbors prepare for the worst and expect the unexpected. Planning and preparation are messages that we must spread, because there's no way we can get through this season without being a community that has a priority of resilience. COVID-19 was unexpected. However, changing climate, weather patterns mean we must factor more frequent disasters into our community resilience plans. It is crucial that we continue to prepare for all levels of government within our communities and across the private sector by learning from what could be the first wave of this virus. Furthermore, building a culture of preparedness to a whole of America response could become a more important component of our ability to most effectively respond to other disasters during sustained pandemic response. We will need your help to prepare communities for potential disaster events. Now is the time to urge people to make contingency plans for emergencies that can happen at a moment's notice. Ready.gov has information online for individuals, families, kids, and businesses on how to prepare for the upcoming hurricane season. Encourage your community to get updated information on how to prepare for the hurricane season during a pandemic. Preparing homes now for a hurricane can mean the difference between minor damage and complete destruction. And our partners at the National Weather Service provide information on their site for Hurricane Preparedness Week at flash.org/Hurricane Strong. Finally, get your community members to evaluate their personal emergency plans and learn about major differences that may be occurring in their local jurisdictions due to the pandemic. Individuals should keep track of their financial and medical and household information by using the Emergency Financial First Aid Kit. You can find that in the FEMA Media Library. So just a few more words before I conclude. As we head into the 2020 hurricane season, I want to leave you with a story. A great Japanese warrior named Nobunaga headed to war against a fierce enemy with only 1/10 the number of men the opposition commanded. He knew that he could win the fight with a well-planned strategy, but his soldiers were in doubt. On the way, the leader stopped at a Shinto shrine and told his men, "After my visit to the shrine, I will toss a coin. If it's heads, we will win. If it's tails, we will lose. Destiny holds us in her hand." Nobunaga entered the shrine and offered his prayers. He came out and tossed a coin in front of his men, and heads appeared. The soldiers were filled with confidence and were eager to win. "No one can change the hand of destiny," one of his attendants told him after the battle. Indeed not. Nobunaga showed him the coin, which was heads on both sides. As a FEMA administrator, I'm very fortunate that I don't need a coin like Nobunaga's. I have immense confidence in the men and the women of FEMA for their adaptability, hard work, and endurance during this unprecedented response. And I have the confidence that our emergency managers will continue to deliver meaningful and much-needed assistance to our citizens when they need it the most. Additionally, we have a deep bench of other departments and agencies and the DHS Surge Capacity Force that we can draw from to support disaster events. We have seen what we can do during the whole of America response to COVID-19. The collaboration between federal, state, and local partners demonstrates that we're able to rise to the challenges in the times of the greatest need, just as we always have. The 2020 hurricane season will mark milestones in a marathon-like run, which is far from over. This year, we all have to lean forward to prepare for this unprecedented time when we are trying to navigate the normal hurricane season while protecting our colleagues, emergency workers, and volunteers, and the people who are in the eye of the storm. So I ask all of you to lead, innovate, be resourceful, especially in the face of potentially demanding hurricane season. This will continue to be a whole America response. We need every member of our nation's emergency management response team to continue to do what they do best, to coordinate, to problem solve, and to act. Our communities and our nation relies on us, and together we will be ready to respond. And I know that I can count on all of you to give everything you have when the time calls. And so thank you today. I appreciate all the speakers, and I hope to see you in person at some time in the future. And I hope you have a successful conference today.
Thank you, Administrator Gaynor, for those words of encouragement and leadership in these challenging and interesting times. Our next speaker will be Josh Morgerman, who founded iCyclone. iCyclone is the brand name under which he chases hurricanes and collaborates with others on weather-related projects. It's a cross-functional team of chasers, researchers, and meteorologists unified by their shared passion for Earth's mightiest spectacle, the hurricane. Its mission is to penetrate, experience, and document the inner course of hurricanes as they thrust ashore via video, data collection, and blogging. Boy, I'm dating myself. Josh was introduced to hurricanes in September of 1985 when Hurricane Gloria visited his hometown in Huntington, Long Island, New York. That memory remained with him as he built up a successful business using cutting-edge media to promote major consumer brands. In his words, he escapes from this business to go back to his roots and feed his soul, searching the globe for violent cyclones. He will be presenting his experience with Hurricane Dorian. Good morning, Josh, and I'll turn you over. So it's your ball game, sir.
For that nice introduction, I appreciate it, and bear with me. I'm new to this tool, but I got a good tutorial yesterday. Here we go. All right, so hopefully you guys see my presentation now. Thanks very much for having me. Very excited to talk to this group. I'm sorry I couldn't be live. I love live groups. I get a lot of energy from the audience, and this is good too. I'm glad that we're doing this, and I'm able to share my experience. So today I'm going to be talking about Hurricane Dorian from ground zero, how I measured and survived the storm of the century. And that might sound like hyperbole, but it isn't. I'll explain in a second. So of course, all of you know about Hurricane Dorian, every one of you. Just this is the big snapshot of its life cycle. If you remember, it started out over the middle of the Atlantic as a wave. It clipped the Northeast Caribbean, exploded into an intense hurricane as it moved west over the Atlantic, smashed the Bahamas, then turned north just in time to miss Florida, clipped the Carolinas, and then unraveled over the Canadian Maritimes. And here's sort of the fact sheet on Dorian. You could see that the dates, it pretty much coincided with the climatological peak of the hurricane season, maybe just a little bit before. You can see that peak intensity, a whopping 160 knots. That's really what makes this storm special. And you can see that it had a lot of landfalls as a hurricane strength system. A lot of people felt Dorian's wrath, but the specific event or part of its life cycle that I'm going to focus on in this presentation is when it made landfall on Great Abaco Island in the Bahamas at peak intensity with winds of 160 knots. And that's significant for this reason. So this is a chart of all the known Category 5 hurricane landfalls in North America as far as records go back, ranked by estimated sustained 1-minute winds at landfall. And these are the National Hurricane Center assessments. And you can see that Dorian's estimated landfall intensity ties it for first place as the strongest known hurricane landfall in North America. It actually ties with the Labor Day hurricane in Florida in 1935. Now, of course, that estimate for the 1935 hurricane is somewhat uncertain. It's based on, modern analysis of old spotty data, but the best estimate that they could come up with in reanalysis was 160 knots. So Dorian is up there with that. So that's what makes this. So when I call it the storm of the century, I mean it, not just puff and smoke here. All right, here's what it looked like when it came ashore, when it made landfall at that maximum intensity on Great Abaco Island. And fortunately, I was right there to document this historic event. And you could see that's as the eye was passing over the stars where I was. It was an unforgettable experience, both just as a human being, but also as someone who's interested in the science of it. So some of you might know me, some of you maybe don't. So just real quick about what I do, and the introduction was awesome, and I just want to fill in a couple of cracks there. So I'm a hurricane chaser, and I only chase hurricanes. I'm the most non-versatile storm chaser you ever met. I don't chase anything but hurricanes. I have this very narrow obsession. I've been doing it almost 3 decades since I was very young. My first hurricane chase was on a train up the East Coast because I was too young to drive. But yeah, I've been doing this a while. I chase all around the world, every hemisphere, north, south, east, and west. I'm very aggressive and competitive in how I chase. I do not have formal meteorological credentials. I studied history in college. So I'm not a scientist, but I consider myself sort of like the hunting dog for scientists because I'm really good at collecting field data, and that's my role in the scientific community. But I treat chasing like a sport, and I'm obsessive about it. These are the 49 hurricane and typhoon eye walls that I have been inside of. I keep very careful stats on my website, iCyclone.com, and these are the 49, like I said, hurricanes and typhoons in which I got into the core in the eye. I consider a hurricane a successful chase if I get in the core of it. If I miss it, it doesn't count. And I'm actually wondering if 50 might be this week, maybe in Texas and Louisiana, who knows? It's looking very interesting right now. So when I started chasing when I was young, it was mostly I would be honest, it was a thrill-seeking thing. I just, like hurricanes were like drugs to me. I don't know what it was. But as I've gotten older and more mature, it's become more about truth-seeking. And what I'm talking about is this. About 10 years ago, the Philippines got hit by a couple of just mega cyclones. And in case you guys don't know, Philippines is the world's capital in the same way that like Kansas and Oklahoma are like the world's capital for tornadoes. For tropical cyclones, it's the Philippines. They get category 5s like every few years. I mean, it's nuts. But about 10 years ago, a couple of major category 5 typhoons struck the Philippines, Megi and Bopa. And there were just no records of what happened at landfall. Everything that we know about these systems is from satellite intensity estimates. And I found that very frustrating. I'm like, these were really big events. They were very important. And all we know is basically our understanding of these events and how strong they were is based entirely on just basically guessing games from satellite pictures. Not to reduce Dvorak intensity estimates to guessing games, but it's not always so accurate. Then I realized that I could make a difference because I'm hunting down these storms and I'm getting inside the cores of these storms in very remote places all over the earth. And I can make a difference. I can get inside these things. I can collect data that counts. Now, because I'm going all over the world when I chase, I can't have like a totally tricked out operation. My devices are pretty small. I go for accuracy and portability, but I get in storms and just sort of measuring air pressure, taking timestamp video and making sure I'm very clear at what my location is all the time. Just from these little bits of data and documentation, I can come back and really oftentimes fill in the missing puzzle pieces of landfall events in remote locations. And scientists use my data. And like I say, I consider myself the hunting dog for scientists. So what exactly am I hunting? Like I said, I'm hunting the core of the hurricane or the typhoon. Ideally, I like to get into the eye if I can. I consider it a successful chase if I get in the core. And in a lot of recent events, my data were the only data that exists from the, or almost the only data that exists from the inner cores or centers of important hurricanes. And if you look at, for example, the National Hurricane Center reports on Hurricane Willow, which struck Mexico last year, or Hurricane Odile, which devastated Cabo San Lucas in 2014, or Hurricane Patricia, strongest hurricane ever observed on Earth that came ashore in Mexico, you'll see that the Hurricane Center reports cite my data quite a bit because my data in those reports are the missing puzzle piece. All right, so let's get back to Dorian. let's talk first about my hunt, how I chased it down. So again, here's the big picture life cycle of the storm from the central tropical Atlantic up into the Canadian Maritimes. Here's a closer look at it. You can see how it's color coded for intensity. Purple is category 5. You can see it smashed the Bahamas, and then it made that hairpin turn, thank God for the US, but it did clip the Carolinas. So I thought I would bring you on the chase with me so you could see the decision-making process, or the neurotically indecisive process of hunting down a hurricane. So when you can see the pink symbol in the lower right, that is where the system is at all times as I'm bringing you through this chronology of how I decided where to hunt down Dorian. So the storm was first named, I was in New York visiting my mother, and I'm like, where do I want to chase this? Now, at that time, it looked like maybe it was going to hit the Dominican Republic as a hurricane, so I booked a flight to Santo Domingo, and I thought, okay, that's a good idea. I'm going to chase this thing in the Dominican Republic. And then I changed my mind. I'm like, no, not Santo Domingo. Let me do Punta Cana. That's on the east tip of the Dominican Republic. That seemed like a better idea. But then as the system entered the Caribbean, it just was not coming together. So I just canceled that plan. And as a lot of you know, that climatologically makes sense. The Eastern Caribbean is notoriously hostile for tropical systems. They just I don't know, it's just like a weird place. They just can't seem to get going there. Cut 2 days later, the system cleared the Caribbean and then got out over the Atlantic and turned into a monster. And at that point, the computer models were showing an intense hurricane ramming into the populated southeast coast of Florida. So at that point, I flew to Orlando, and that's my normal MO. I usually don't fly into coastal airports where I think the hurricane is going to hit. I fly into a nearby inland airport. That kind of makes a lot more sense to me. And from there, I drove to West Palm Beach. And of course, at that point, the computer models changed again. They started to show the cyclone stalling over the peninsula. Then they started to show it stalling right off the peninsula and then just hooking north. And then I realized that, okay, if I want to taste this thing, I need to get off the Florida peninsula and into those islands east of Florida, better known as the Bahamas. And that's what I did. And I hopped on a flight to Great Abaco Island. And you could see by the time I flew to Great Abaco Island, the hurricane was already getting pretty close. In fact, it was the very last flight. I saved my plane ticket. It feels like so, I don't know, like this seems so symbolic now. This was the last flight into Marsh Harbor. Marsh Harbor is sort of the de facto capital of Great Abaco Island. It's sort of the administrative and commercial center. It's about 6,000 people, or it was, I should say. But yeah. So I landed there, and I'd like to show this graphic to show, you think of the Bahamas is far away. It's like, it's right, those islands are right off of Southeast Florida. They're right there. And you can see that I flew to Marsh Harbor, and then you can see the little green line is where I drove to. That's called it's called Treasure Key. That's about a 20-mile drive there. And I landed on this location, and here's what it looked like on the ground, dramatic selfie that I shared on social media. This is where I was going to ride out Hurricane Dorian. At this point, it was Category 4, and I was in what I thought was a sturdy condo, kind of close to sea level there. I know that's kind of stupid, but I was like, I really wanted to just have this front row seat and capture incredible video and, and amazing data. I was just like, I'm going to really document this thing, and this is like a perfect location. And here's the row of condos. This is I was going to stay in one of those. These are 3-story buildings made of mostly concrete, although as I started to assess them and knock on the walls, I realized parts weren't concrete, which started to make me nervous. Here's sundown the night before the hurricane, and just showing how idyllic this town was. And I look at this picture and I get so sad because this was the last night of paradise for this place for a very long time. And when I say very long time, I mean like probably more than a decade. This place was obliterated, and I look at this picture, I get sad from it. So I tried to force myself to get a couple of hours of sleep before the hurricane hit. And I remember going to bed, and then I woke up in the middle of the night to this howling sound of the wind. Now, I've been in a lot of hurricanes, obviously. Something about that howling sound, it just had a sound that was spooking me. And I remember laying in bed looking on my phone, and the recon data were coming back showing that they were finding Category 5 winds. Like it looked like something was going on with this thing. And between that howling sound and the recon data, I was like, you know what? I don't feel so good about this location. I'm a very aggressive chaser, but I started to just not feel good about where I was. Like maybe it wasn't as secure as I thought it was. So late that night, I packed the car and I drove back down to Marsh Harbor in just the wee morning hours. So there are 2 reasons for that. One is, like I said, I didn't really feel safe in Treasure Key. The other reason was that the hurricane was moving due west, and I wanted to get in that eye. It was really important to me to get into the eye to collect those really valuable data. So, and it looked like it was going to miss to the south if I stayed where it was. So I went down to Marsh Harbor. So this is a zoomed in look at the track of the hurricane with hourly positions as it approached and went over Great Abaco and Grand Bahama Islands. Now the little star, that's where I was, where it says iCyclone, that's my location. And you can see I nailed it pretty good. Let's zoom in there. That 2 p.m. position is right over me. That's distance between my point and that is just, that's static. It's basically, that's like right on top of me. And this is the final zoomed in view. Main location A, that's where I rode out the first part of the storm. During the eye, I had to relocate to another building because the building I was in was so badly damaged. I'll bring you through that in a second, but you could see, nailed this thing real good in terms of trying to collect data. All right, so now I want to bring you through the impact and just kind of bring you through the experience of what I saw and also what I measured. So when I got to Marsh Harbor, the storm was still a category 4, but it was, like 130 knot category 4. It was a strong one. And I was like, all right, I got to take this one seriously. So I drove around Marsh Harbor. It's mostly very flat, but there are some hilly parts. So I went to the hilly neighborhoods and I looked around for a big, strong building, and I found the school, the primary school. And that's where I decided to ride out this storm because it was concrete and it was on a hill. And that seemed like a good idea. Here's what the outside of the school looks like. See all those lush green trees? Say goodbye to those. I'll show you what it looked like afterward in a few minutes. All right, so I hunkered down in this school and I recorded the event with a couple of barometers, a couple of Kestrel 4500s, very portable devices, and also very accurate. So just what I needed. I calibrated them. I went down to the water and then I used the devices as sort of pressure altimeters to figure out my elevation at the location where I was running at the storm, and then corrected for sea level pressure. So had this calibrated, started collecting data. I also had a couple of cameras, and I just started documenting what was happening. Now, documenting this storm was challenging. This was such a violent hurricane that I couldn't shoot it in the normal way. But just with these simple tools, I was able to do some pretty deep analysis of the event afterward, which I was very happy about. So after the hurricane, the first thing I do after a major chase like this is I go over my video footage, which is all very precisely time-stamped, and I also go over, obviously, the pressure data, and then I put it together. I reconstruct a chronology of what happened, saying what happened beat by beat, what the pressures were, and everything else. And then I sort of identify the phases of the hurricane. So here you can see pink is when we got in the eye wall, red is when we got into what seemed to be the peak winds, and blue is when we got into the calm eye. Now, these are admittedly, I wasn't measuring wind data in this, so these are admittedly subjective assignments, but I think they give a good, they're useful because they give you a rough idea of the storm's dimensions and the duration of the event and stuff like that. And you'll see as I bring you through some selected video clips, why I assigned these phases like I did. You could actually see with your own eyes, like when we get into the core of the hurricane, when it seems to be maxing out and when we get into the eye. Here's those same data and observations in a more visual format. You could see as the pressure fell, we got into the eye wall, which was the pink, and then we got into that zone of maximum winds, or what seemed to be the maximum winds, which was the dark pink, and then into the blue, which is the eye. The lowest pressure I measured was 913.4 millibars. That was a record for me. That was like about 10 millibars lower than my second lowest pressure that I've measured in any chase. Don't know if I'll ever measure that again. Now, some of you are probably looking at this and saying, okay, I see the downward slope of the pressure. I don't see the recovery. I'm only seeing half the V. What happened? I'll explain. All right, so now I want to bring you through this historic experience. I'm going to show you a video of selected moments. All right, so back to the chronology. So the first thing I want to show you is the outer eye wall. This is as we got into the eye wall, but before we got into the worst of it. And when I say outer eye wall, I want to clarify here. I'm not talking about, there were no concentric eye walls when Dorian hit the Bahamas. It was a single consolidated eye wall. What I'm talking about is the outer part of that. And actually, just to help you, here's a radar shot. And you could see the black stars where I was, that's Marsh Harbor. And you could see that's just as we were getting into that outer part of the inner ring of the hurricane. And what I'm going to do is I'm going to show you now a video of that. So this is as we're getting into the eye wall, but it's before we get to really bad stuff. And what you can see is that the hurricane is already getting pretty destructive. Hopefully this launches okay. Just waiting for the video to come up. Sometimes a little bit of a lag. Oh, there we go. Okay. just before noon, and we're at 960 millibars. The wind is ripping really hard, but the scary thing is we have like another almost 40 millibars to lose. We have a lot of isobars to go through, a lot of gradients. I think the wind's gonna get worse. Wow. Alrighty. Now, one thing I forgot to say is where I was exactly. So let me just get back to my presentation here. Okay. The vantage point in that video is I'm in a, there we go. The vantage point in that video is I'm in a classroom. So basically, at first I was like, I'm going to document the storm outside, which was like the stupidest thing I ever thought. I just was like, you know, it's a school complex. There's lots of little alcoves and like little tight spaces where I can get in to shoot the video. And my brain wasn't working because when you're inside a really severe hurricane like this, the wind flow is very turbulent. It's not all in one direction. It's swirly and crazy, which you'll see in a minute. But at a certain point, the military guys just said everyone had to get inside or just leave. And I wasn't going to ride out the storm in a car, and you'll see why in a second. So I had to just get in a classroom. So I was with 2 families and 3 other guys, and we were just in this room. The room had windows on the upwind side and windows on the downwind side. The upwind side windows were boarded up. They had cyclone shutters and boards. The downwind side is what my view is. I'm looking out of the window on the downwind side through cracks in the cyclone shutters. Now, that's not the most ideal way to document a hurricane, you know, like through cracks and shutters. But hey, you know, with a 160 knot, 185 mile an hour hurricane, this is what you got to do. By the way, it only became a Category 5 a few hours before we lost communication. All of a sudden, the last couple of reports I got, just as my connection was getting spotty, was that winds were up to 150 knots, then 155. And actually, that was the last I heard. It actually got stronger after we lost communication. So I didn't find out afterward what the peak intensity was, but by this point I knew we were in a strong Category 5. Now, one thing about that video, about that moment that spooked us in the room was when you saw those papers flying. Now, of course, wind blowing paper around isn't a big deal, but what that told us was, okay, where did the paper come from? Well, clearly part of the building had already ripped open. Something had already happened. Some part of the building had already failed. That's why stuff from inside the building was blowing around. So we knew at this point that we were in trouble. And even from this vantage point, those cars were a little protected from the building, but you could see the wind still really starting to rip. Okay, so next part I want to show you is the transition from the outer eye wall into the inner eye wall. And what you can see here, what I want to show you is how the turbulence increases dramatically as we go from the kinds of conditions you were just looking at into that inner stuff where it just goes totally nuts. And I want to zoom in on the pressure data here because it's really interesting. So these are the data you saw before, but it's a zoomed in look. And here's something really interesting. So in the outer part of the eye wall, the part that I was just showing you, the pressure kind of fell fairly uniformly. It was like a pretty behaved drop. Notice as we get into the inner eye wall, into what seemed to be the peak winds, that the drop becomes super, it gets really jagged. It's like up and down. It's really wild. It reflects the turbulence inside that inner eye wall. And also it shows you there's a lot going on in that inner eye wall, and it's stuff you can't see. It's like, you know, localized disturbances, eddies, maybe mesovortices. There seems to be some of that because some of the damage you'll see just stuff blew in different ways. There's something going on in there, and even though we can't see what's happening, some of the videos I'm about to show you, it's all just white out, but the barometer senses it all, and it's sensing these kind of things, these dynamics happening outside that are really wild. And this jagged pressure trace really coincides with the more violent conditions. All right, so now let's look at the next video, and this is as we're transitioning from that outer part of the eye wall into the inner part, and you could just see the conditions really starting to pick up and get nasty. And there's a slight, it takes a second for the video to come up. So we'll have one of these little pauses each time I launch a video. So I'm sure it'll be up any second. One of the things you'll notice as the video starts, though, is how just one thing to look for is how the gusts just rush in and how it seems to, here we go, and how it seems to be like a whiteout coming on.
Well, the cars are like picking up. I'm ready to learn.
Notice how everyone's rubbing their ears. All of our ears were hurting because of the gusts. I'll talk about that.
Holy crap! Wow, this is really nuts. This that we're in it.
So yeah, you see how everybody, is my microphone back on? Yes, it is. Okay. You see how everyone was like rubbing their ears? It was really painful. And it's not from the low pressure of the hurricane. It's as you have really intense, very sudden gusts blasting over a building. It causes actually pressure changes in and around the roof and under the building. And that's what you're feeling. And it really, like, you feel your eardrums just pulsing in and out. And it's really painful. And everyone in the room was like doing that the whole time as we got in that inner eye wall and we started to get that extreme turbulence. It was, that's when you really start to feel it. And that's one thing, when you're in a really intense hurricane like this, a lot of it is what you feel. You actually feel it in here. You feel it in here. You know, the video only captures like a very small part of it. All right, so the hurricane moved over us, and finally we got into that inner eye wall. And this has been like my lifelong fantasy, was to get inside, you know, the inner core of a high-end hurricane like this, like not just a Category 5, but like way up into Category 5, you know, on an island with like no friction to interfere with the wind flow. And it's like the middle of the day. It was like just after 12 noon. It's like everything's perfect, and I'm like, okay, this is perfect. I could really document this. Well, not really. It wasn't what I expected, and the reason for that is because you couldn't see a thing. So next video clip I'm going to show you is to show you how basically you couldn't see anything. I might as well have just shot a shower curtain because everything just turned white. It was impossible to see anything. And now I'll show you that, basically just to show you that you can't see anything. And just waiting for the video to come up. There we go. At that point, the shutters, the boards were starting to blow off the windows, and we were worried that they were going to open up. Yeah, so at that point, like I said, oops, went back to the beginning for some reason. We were really deep in the hurricane, and as I said, the boards had started to blow off the windows, which was really quite a concern. That was actually quite alarming, because if those boards on the upwind side of the windows blew off and the shutters caved in, we were just going to basically be in a shooting gallery. So at that point, we had a few kids with us. We were wrapping the kids in blankets and putting them under a table. And then, as you'll see in the next clip, we were actually having to hold furniture against those windows. So even though you couldn't see anything, there's just that curtain of whiteness. Stuff was happening behind it, and my barometers were picking up incredible things at this time. So one thing I noticed when I zeroed in on the data from this this portion of the experience, one thing I noticed was that the pressure changes over very short periods of time were incredible, and those allowed me to calculate in a very rough way pressure gradients. So Dorian was moving steadily west at 6 knots as it hit, and it passed right over my location. So based on this, you can roughly assume that that my devices in a fixed location sampled roughly 1 nautical mile segments of the cyclone every 10 minutes. So basically, if you take the pressure changes over 10-minute periods, you can use those as a proxy for gradients across 1 nautical mile samples of the cyclone. And from that, you'll see, I'll show you in a second, but I had many examples of gradients over 10 millibars per nautical mile, which are just crazy, and some were much higher than that, which is nuts. And I want to clarify, of course, these are rough calculations, but they just give you some idea of the incredible pressure dynamics in this thing. So here's the same data I showed you before, but zoomed up even closer into the really hardcore inner part of this thing. And these are the highest gradients that I was able to calculate. And you can see the maximum one is 12.4 millibars in a nautical mile. Totally nuts. I've not measured anything close to that before in any other hurricane. And in fact, in all the major hurricanes I'm in, I do this process. I try to calculate gradients based on speed of motion and changes in pressure over time. And you can see how Dorian stacks up to other hurricanes I've been in. The second place is Patricia. Patricia, the strongest tropical cyclone ever observed on Earth, with sustained winds of 185 knots. It weakened before it hit me, but it still had a very intense core when it passed over me in Mexico. That one I had 10.5 millibars per nautical mile. Michael in Florida was about 8. Maria in Puerto Rico was 7. That was a very large hurricane. The gradient was a little more spread out. All these gradients are nuts, but the Dorian one, man, that takes the cake. I was like, wow. So finally, the pounding winds started to die down. And now what I want to show you is that the most magical part of a hurricane, which is when you go from the inner eye wall into the eye. So one thing to notice, which is really interesting about this video, you'll see we're all holding furniture against the upwind windows to keep them from blowing in. But there's sunshine coming through the cracks in the shutters. So the winds outside are probably roaring at like 130 knots, and it's deafening, but there's sunshine, and it's because we were getting so close to the eye, and it was really pretty weird. So yeah, let's look at that transition into the eye. It's very cool. Alrighty. And just waiting for the video to come up. There we go. The boards blew up the windows. We're trying to keep them out, keep out the wind. It's 107, sky is brightening. Pressure is like, it's been fluctuating between like 914 and 918 millibars. I think we're almost in the eye. Oh my God, I think we're almost in the eye. cars just thrown all over the parking lot, like every which way. Wow. So that's the magical transition. Like I say, it always feels magical when you start to get that calming. And that's a still photograph I took as the eye was coming in. There's something almost like religious about that, you know, the light coming through and everyone looking through the windows as we're getting into the eye of a high-end Category 5 hurricane on not a tropical island, but a subtropical island, I guess. And here's the radar shot from that time. Of course, I didn't collect this image at that point. I didn't have any communications, but you can see, wow, we nailed this thing squarely. I mean, Marsh Harbor got right into the heart of this hurricane. So now I want to show you just the eye, what that was like, just walking around in it. And this is a long clip. It's a long clip from the moment that I step outside the doorway and just walk around and look at what happened. Look at the trees, look at the cars. Now the cars parked right against the building that you see in my video, those were a little protected. One or two of them blew away, but some of them stayed actually. In other parts of the parking lot, they just blew around more, but just everything's just thrown everywhere. Buildings heavily damaged. I guess just check it out. There's also, by the way, you'll see there's a moment where I do a slow-mo and you could see the stadium effect of the eye above us. It's pretty wild, the whole thing. So let's take a look at that. This is a fairly long clip because I want to give you the experience. It's unedited. It's as I experienced it. It's like as I stepped outside that door and just started walking around and looking at this radically transformed landscape. The edge of the eye, but still quite turbulent. Notice the car is just thrown all over the place. Concrete knocked off the building. Car just up on the lawn. I don't know where it came from. Here's the stadium eye. You know, there's something really just so kind of serious about it. And notice the cars were just mutilated. Here's a close-up shot or a still of that moment with that stadium eye. It was a little misty. It wasn't like that sky above wasn't perfectly blue. There was a mistiness because the hurricane was starting to interact with land, but it was still, that's the eye wall of a 160 knot hurricane right there. Yikes. And here's some close-up stills from there. Notice that the cars, I'd never seen this before in hurricanes. The cars were not just smashed up, they were mutilated. You know, just the hoods just like torn off. Some of them had parts of the engines ripped out, just like crazy stuff from the force of the wind, like really scary stuff. Like you realize like why you can't be outside. You can see the cars just thrown around like toys. Concrete parts of the buildings just ripped off or smashed off. I mean, that's like concrete there. And the parts of the building that were not concrete, forget it. They were just like, this part of the building was wood, just no match for these winds. And I want to show you a couple of really interesting things, a couple of befores and afters from my location. So this is my view from the window right before we got into the eye wall. Notice the cars there. Now that little dark car, that little Honda just to the left of the tree, that was actually my car, just parked right there. Notice the truck next to it. And then after, when we got in the eye, you could see the other car had blown away. It had sort of gone to the other side of the parking lot. My car was fine. It hardly moved. And it shows you how erratic and weird the winds inside a hurricane, an intense hurricane's eye wall are. It's almost like a tornado where, you know, my little tiny car just stayed put and the truck next to it just blew away. And, you know, God knows the kinds of weird, like, wind flow dynamics that caused that. Here's another one. So if you look all the way to the right, this is again a view from that room during the eye wall. If you look to the right, you can see that felled tree, that small tree. So you see that there, and then this is during the eye. It's a different angle, but you could see that same tree, and now there's a car on top of it. And I don't know which direction that car came from, if it came from the other way or whatever, it just kind of landed there on top of that tree. And that was one of the things that happened. I told you before about that whiteout, or I showed it to you. A lot of the really crazy stuff like that happened behind that curtain of whiteness. We couldn't see anything. The really crazy stuff was just hidden behind a white curtain. And when the curtain cleared and we got in the eye, then you saw the results of it. All right, here's the front of the school. This is from those wee morning hours before the hurricane struck, and you can see that's what the trees look like before, really lush trees. And here's a similar view of the front of the school after, and you can see they're all sticks. Now notice these trees are designed by nature to survive. They actually let go of their leaves so that they could stay up, and they mostly did, you know, but they're totally stripped. I mean, it looks like we're in Siberia in the middle of the winter rather than a subtropical island. So as I said, I measured 913.4 millibars in the eye, and I know probably some of you are wondering, okay, where's the recovery? Why is there just like a half of a V? And it was because the building was so badly damaged that my roommates and I decided to relocate. We deliberated about it, and we didn't feel a lot of the building was damaged. Some of the other classrooms had ripped open, like the roof had come off with people inside them. So basically, we all decided that we could not ride out the second half of the hurricane in there, and we had to relocate. And it was a painful decision because I really wanted to just stay in that space and continue to collect the data there. You know, you can't move the instruments because then the data are no good, then it's not controlled anymore. Part of it was just a human concern. So out of the 11 of us in that room, there were 2 families with a few kids and then 3 dudes and me. My car was one of the only ones that survived. There was between the 11 of us, there were 3 cars, one of them being mine. So several people were counting on me to bring them to safety. So I had to make a decision between my scientific desires and my human ones. And I just, you know, I had to just stop collecting data. So maybe the pressure got a little lower. I don't know. It kind of gnaws away at me, but I know I made the righteous decision. We piled in our cars, some of them damaged, and got on the road to try to find somewhere else. And I'll tell you, this was the scariest part of the chase because I had no radar, no nothing. I knew we were in the eye. I knew it was a strong hurricane. I had no idea when the backside was going to hit and what the roads were like and everything else. And my biggest fear was getting caught in those backside eye wall on the road because we'd be dead in winds like that. It was a really scary thing. And the roads, of course, were blocked with debris, but we were always able to, you know, it was a wide highway that school's on, and we were always able to drive around it, thank God, and we're able to get to a new place. So this is where we relocated, and notice A is where we were, B is where we got to. Only 2/3 of a mile, really not that far, but I'll tell you, it was like the longest drive I ever took in terms of like emotionally. And what we got to was the Bahamas government complex in Marsh Harbor. So this is the sort of administrative center of government on the island of Great Abaco. And this is a well-built Bahamian, like, building designed for hurricanes. And I'll tell you, the Bahamians really, really know how to design for hurricanes. They know what they're doing. They're really strict with their codes. And this building is an example. That roof stayed on and those walls stayed up. You can see there's a lot of cosmetic damage. Those fake Corinthian columns just got trashed, but this place stayed up, okay? And that's where we went. Now, when we got to this building, people from every direction were literally running toward the building. We were in the comm, people who had swum to safety from storm surge, people who had escaped from their collapsed homes. Literally from every direction, people were running and driving to this building like a pilgrimage to get inside this before the backside of the cyclone hit. And it was scary, you know, because you felt like the time was running out, but we all got inside it, thank God. And then the backside of the hurricane hit and we were safe. And I'm not going to show any more video in the interest of time. You guys can see these clips and more if you go to my YouTube channel. Just go to YouTube and look for iCyclone. You'll find a 31-minute video of my whole experience at Dorian that includes the clips you saw and it's the whole experience. So if you want to kind of really delve into it. But on the backside, we were in this really protected building with really solid impact glass. So you could actually look through the glass at a Category 5 hurricane and it wouldn't break. This is real hurricane construction. This is good stuff. All right. Oh, actually, did not mean to play that. We're not going to play another video. Okay, so let's get to the aftermath. We went through the backside of the hurricane. The worst of the storm passed by about 4 o'clock, but the misery was just beginning. So the inner core of the hurricane passed us, but then when it got to Grand Bahama Island right next to us, it just basically stopped moving. So we were stuck in sort of sorry about that. We were stuck in basically the hurricane for 2 days. Not the hurricane winds, but we were stuck in tropical storm conditions, constant heavy downpours and gale force winds, sometimes with gusts to hurricane strength for basically a couple of days. And imagine the misery of survivors. It was miserable for me, but don't feel sorry for me. I chose to be there. But for these poor survivors who lost everything and they're homeless, a lot of people were injured, food and water are limited, and it's just like it's stormy for days. It was like you felt like they couldn't begin the recovery process. In this government complex, there was no power except in some rooms and no plumbing. The medical clinic next door, which is the hospital for Great Abaco, was completely overloaded with people with traumatic injuries. I mean, it was really a grim scene. I lived in my car for a couple of days. That seemed to me to be the best bet. The conditions inside the building were getting a little not so good, and I also didn't want to take up space. Important thing when you chase is don't be a burden, don't take up space, don't only be a help, never be a burden. So I lived in my car. I rationed my food. I lived on peanut butter and had everything like really organized. And I finally got out a few days later. So let's look at the aftermath a little bit to wrap this up. So the damage across Marsh Harbor was catastrophic, and I don't use that term lightly. I don't like to use that word unless I really mean it. I've seen a lot of hurricane and typhoon aftermath. This was catastrophic. The storm surge was tremendous. I was not able to do any exact measurements of watermarks and stuff like that, but it was clearly well over 20 feet, and it swept the low-lying areas. The commercial promenade along the waterfront was just devastated. In the poor neighborhoods, this area called the Mud and the Pigeon Pea, which I'm going to talk about more in a second, was completely swept away, just swept away, and I'll show you that. And the neighborhoods above the water had extreme wind damage. I mean, almost every house was heavily damaged. As you saw, cars just smashed and mutilated like toys. Now, one thing I noticed, and no surprise, is that construction mattered. The well-built houses that were up to the Bahamas' very strict standards performed fairly well, even from a direct hit. From a 160-knot hurricane. So let's look at wind damage first. So common sight throughout Marsh Harbor is just cars in the middle of the street. I don't know where it came from, it just ended up there. It's mutilated, the trunk is twisted, crazy stuff. That's the Bahamian government complex in the background. Notice it's unscathed. Good construction. Again, I want to keep emphasizing that. This was a fellow I met. He and his wife wanted a ride to their house so they could see what happened. This was in a wealthier, more well-to-do area of Marsh Harbor. It's like a suburban subdivision called Central Pines. I drove into the house. This is what was left of it. It was unfortunately made of wood and not like, I don't think especially code compliant, and it was just basically destroyed. Here's an example, another shot from Central Pines from that more wealthy neighborhood. And you can see, whoa, just the car just thrown like that between two others. How did that happen? Looks kind of crazy. Notice the houses in the background though, they look pretty good. I mean, look at that house on the right, that roof, that's a Bahamas hurricane roof. And that thing stayed on. I mean, those two houses there performed very well considering that they were in a direct hit from a hurricane of this intensity. Here's other homes that I think must have been fairly well built. You can see that they're banged up and they lost outer materials and stuff, but these houses, considering what they went through, this is as strong as any hurricane can get, they did pretty well. Here's a house that unfortunately was not as well built, just totally reduced to rubble. Looks like a tornado hit it. Just nothing, literally nothing left, just swept from the foundation. This is not storm surge. This wasn't on high ground. This was wind. Here's another one where the roof probably was just not constructed properly. Second floor damage to homes. Now let's look at the storm surge damage. This is the central business district of Marsh Harbor. This is where all the kind of hotels and restaurants were. And you can see it's just rubble. It was a combination of wind and storm surge here. And here's what the storm surge did to sort of concrete block construction, just literally bulldozed it. And now I'm going to show you some interesting aerials, some befores and afters. So this is Marsh Harbor before the hurricane. And you can see my locations pointed out there. You can see to the left is the, location A, that was a school. Location B is the government complex. That was before the hurricane, and this is after. And you can see, well, first of all, it's brown. That's because all the vegetation was killed. And also, you could just see just by you can tell by the sort of the way the lines and everything look that you can see that that represents a lot of destroyed buildings. Actually, let's zoom in a little bit. All right, so this view, this is Central Pines. This is that more affluent suburban kind of subdivision that's sort of on the left. On the right there, you can see that's the school where I wrote out the hurricane front side. This is before the hurricane, and this is after. Again, you can see all the killed vegetation, and you can see the damage to the homes here. You can see most of them don't have roofs or worse than that. Here's a shot, a different part of Marsh Harbor. So in the lower left is the Bahamas government complex. That's the building we went to. That's in the lower left there. And then in the upper right, that area that with very irregular streets, and it looks like a lot of urban density there, that's the mud and the pigeon pea. This area, by the way, so a couple things about it. One is that it's very low lying, and two, it's a poor area. It's mostly an area inhabited by Haitian immigrants. And one of the problems, it seemed, was that the Bahamian authorities tried to get people to evacuate. And it seems like in this area, maybe because the folks were not totally trustful of the government, they don't like to leave their homes. Maybe there was just some concerns because a lot of them weren't documented. They didn't want to leave, and that had tragic consequences. Anyway, here's the before shot, and here's the after. And you could see, again, the mud and pigeon pea area. I'm going to go back and forth so you could see that's just demolished. I mean, there is nothing left of that neighborhood, and I'm going to show you in a second what it looked like at ground level. Well, here we go. This is that area, the mud and the pigeon pea. This was a neighborhood. It wasn't an affluent neighborhood, but it was a neighborhood with homes, with businesses, buildings, no high rises, but with, you know, it was a center of commerce, and it was a place where people lived. And it's just like there's nothing left. I mean, you could see that one looks like a bar or restaurant in the distance that kind of, that's stood up, but otherwise everything is just gone. I mean, this was some of the most extreme hurricane damage I've seen anywhere. It rivals what I saw in Super Typhoon Haiyan, another Category 5 in Tacloban City in the Philippines. This was up there with that in terms of just this total destruction. That's really, it's just hard to get your head around. Now, they don't know how many people died. We'll never know. I believe that the official death count, which I think is like under 100, is a gross undercounting. It has to be, because I talked to so many people who, just the days that I was at that government complex, I talked to a lot of people who had harrowing tales of escape. Some of them actually saw loved ones die who got swept away in storm surge, or they knew of people who had died. And when you walked around this area, there was also this, I don't know how else to say it politely, there was this scent of death. I think there were massive casualties here, but unfortunately, a lot of these poor people were undocumented, and they're just somehow it was never tallied. So I think we're never going to know how many people died in this area. But it's as an example of the force and power of hurricanes, you don't get a more jaw-dropping example than this, in my opinion. There's a final shot I took, just sort of the human side of this. This is a husband and wife, you know, embracing on top of the wreckage of their home. This really struck me. You know, I'm obviously very meteorologically obsessed. You know, I view a hurricane like this specimen to kind of analyze, and then occasionally moments just kind of drive home the human impact of it for me, and this moment did. And I like to look back at this picture just to kind of remind me of, you know, that part of it. So there we have it. That was my presentation on Dorian. If you want to follow me on my upcoming chases, you can get me on Twitter or Facebook at iCyclone, and on Instagram at iCyclone1, because some kids in some other place has iCyclone, so I had to have iCyclone1. But there you go. I'd be happy to take questions if anyone has any. And thanks very much for enjoying my presentation.
Again, if you have any questions for Josh, go ahead and use the chat feature of our webinar to type your questions in. And I'll try to do my best to relay them to Josh so he can answer them. an amazing adventure, Josh, that you had in the Bahamas.
Yeah, it was. I'm glad I got out in one piece. I mean, I have to say, I'm very obsessed with documenting and recording these events, but sometimes I wonder if I'm just pushing too hard, to collect these data. If my obsession to collect data inside the eyes of these sort of cataclysmic events, one day I'm going to pay a price for it.
Okay. One asked, do you have a will? One of our questions, do you have a will?
Actually, you know what? It's like I have to get those affairs in order. I probably should, though. Now that you say it, maybe it's that I some side of me fancies myself invincible, or maybe it's my internal optimist that has made me procrastinate with that matter.
A living will probably wouldn't be a bad idea.
Right. Well, such a grim topic.
Okay. Here we go. Is your travel subsidized by the scientific community?
Great question, and it is not. So I make my living as a TV personality. So I didn't, just because of time, I didn't want to get into it, but I do a lot of TV work. I star in a series called Hurricane Man. It's a UK TV BBC series, which maybe some of you saw on Science Channel. You could also get it on Amazon Prime. But it's a TV show that's been shown around the world. It's an 8-part series that follows me as I hunt down hurricanes during the 2018 season. That and other TV work, appearing on TV, and also some speaking engagements and things like that, and licensing video. That's actually how I generate income. I do not make money from my data. That is just sort of like, that's I kind of do that just for the love of it. But it's a good question, and I've thought about trying to get some grants or something, because the work I'm doing is used by official agencies, and they make good use of it. But as of this point, no, it's sort of a labor of love is how I would describe it. I basically make my living as an entertainer, to be honest.
As you've experienced hurricanes, could you comment on the heights of hurricanes?
The heights?
Yes, that's the question.
I'm not sure I understand. Can we get clarification on that?
If the person that answers that question could give us a little more, we'll do our best. Josh will do his best to answer the question. Why we're getting perhaps a secondary response to that. We have another question. What is your ideal hurricane chase?
What is my ideal one?
Yes.
Actually, Hurricane Dorian. This was I would call this the defining chase of my career, because a few reasons. One is that it was just basically as intense as hurricanes get. I mean, this thing wasn't just a Category 5, but way into Category 5. I got into the eye, so I could collect those central pressure data. It was a daytime impact, so I was able to see and record what was happening, and I got out alive. So I'd actually call Dorian in some ways my perfect chase. I don't know that I'll ever have a chase more perfect than Dorian.
As far as being in the eye and being able to get your measurements and things like that.
Yeah, just that, and also just a daytime impact and the quality of the specimen. I mean, 160 knot hurricane. I mean, you're not gonna get a finer example of a tropical cyclone.
All right, I think what the attendee was trying to ask for is how high the hurricane was in terms of its height, as far as the whole eye wall and the height of the storm from sea level to the.
Oh, that's a good, yeah, it's a good question. I mean, I don't have an answer for that, because what I do and what I'm really good at is is getting into these storms, hunting them down, and then collecting data in a good, high quality, accurate, controlled data in extremely dangerous situations, and then coming out alive. So I consider myself the master of the kind of on the ground experience, and that's my expertise. You know, no one knows what it's like to go through a hurricane and how to survive it and how to get into the eye wall and get into the eye and get the data than I. When it comes to the sort of overall the kind of the upper level dynamics of the hurricane, or how high it goes into this into the upper levels, that's kind of not as much my area of expertise. So I would defer that question to someone else.
And I hope I interpreted the person's question correctly too.
Now, if you're talking about, I mean, another way to interpret it is the height in terms of like, okay, the maximum intensity of hurricanes, and that's a topic I can sort of talk more about. So how strong do hurricanes get in terms of maximum winds? What heights do they reach? So like I said, Hurricane Dorian, in terms of North American impacts, is the strongest known impact in North America, tied with the 1935 hurricane, 160 knots or 185 miles an hour. Now, Super Typhoon Haiyan, when it hit the Philippines, was estimated by the Joint Typhoon Warning Center to have a landfall intensity of a little higher than that, 165 knots or 190 miles an hour. Now, in terms of the highest winds ever reliably recorded or estimated in a hurricane or tropical cyclone anywhere, that would be Hurricane Patricia in the Eastern Pacific in 2015, 185 knots or 215 miles an hour. And I think that represents a true maximum. I don't expect that we'll ever see anything higher than what was analyzed by Recon in Patricia. And I was in Patricia, it weakened to 130 knots or 150 miles an hour by the time I was in it. It weakened as it approached the coast. But Patricia to me represents the true, like, wow maximum that hurricanes can get, the true height in terms of wind.
Another question we got is, as you only use Kestrel and camera for hurricanes, what do you think how a stable weather station like 3D printed weather stations can help in hurricane forecasting?
Well, that's a really good question. I use the Kestrels because for me, the things that matter to me are accuracy and portability. And what I like about the Kestrels is I usually travel with 4 or 5 of them because I like redundancy with data, especially when I'm in a historic storm like Dorian, when I know I'm gonna capture really crazy data. It's really important to have corroboration. So my lowest pressure was 13.4 millibars. There was another instrument next to it that had 13.7. That's a good corroboration, and that gives me confidence that the data I collected were accurate. Now, I would like to expand and record other kinds of data. So a lot of people ask me, why don't you record wind data? The reason is because it's important to me that whatever data I record have scientific value and that they're good data. Capturing good, high quality wind data is very, very hard. You know, you have to have an instrument that's at 10 meters. That's a surface wind is at 10 meters. Has to have open exposure, meaning nothing near it. And just that right there, you know, the way I'm kind of jumping on planes and, you know, just helicopters and stuff like that to get to where I need to be. I can't carry big installations with me or masts, you know, like 10-meter masts and stuff like that. So that limits my ability to collect good wind data. And my feeling about it is if I can't record really good high quality wind data, I'm not going to bother. I'm just going to focus on how do I get really, really good air pressure data. That said, you know, listen, I would love if I had installed some kind of an anemometer thing in the parking lot, you know, outside that school in Dorian. I mean, God knows what it would have showed. And even if it wasn't at 10 meters, what if it was at like, you know, 3 meters, you know, on a mast above the car? You know, that those data would have been useful. And of course, scientists could have maybe corrected for 10 meters or something like that. It's something I want to look into. I think I would definitely like to expand my suite of equipment. And the 3D printing thing is really interesting. It's an interesting area to like go into. It's something I think about constantly. If I'm going to be there, how can I meaningfully record these events?
Okay. Don't see any more questions at this point. Other than we've had a number of comments saying great presentation. You know, thank you so much. I'll pass those along to you. And we'll maybe wait a minute or so to see.
Yeah, sure, absolutely.
because we're.
It's my pleasure, and I hope I hope it's an interesting experience for people. And I know very few people had the opportunity to go through a hurricane like that. And what I wanted to do in this was to show you, okay, yeah, this is what it's like to go through basically a hurricane that's as bad as hurricanes get, and also to show the cool data, just the sort of the picture that I was able to paint of this thing from like the pressure profiles and stuff. I mean, it's really interesting, and I hope it was interesting for folks. By the way, if anyone wants even more data and analysis, you can go on my website, and I have a whole report. So every hurricane, every significant chase that I go on, I will take my data and write a whole technical report. Not every chase, but the significant ones. So if you go to my website, iCyclone.com, and then it's very easy. Just go to the chases page, and then there you'll see all 49 hurricanes I've been in. And on each, you could go to the page for a hurricane. And if I wrote a report for that hurricane, you'll see a big orange button that says report. And if you go to the Dorian page, there's a button that says report. Just click it, and you could download a really detailed detailed report that has all the data and charts that I showed you in this presentation, and a lot more. And my Dorian report is particularly interesting. There's a lot in it. So that's something that you can enjoy. Like I also said, if you want to see the video, if you want to see more of it, just go to my YouTube channel. Just go to YouTube and type in iCyclone. It'll come up. And like I said, there's a 31-minute video of my Dorian experience from before, during, and several days after it. And it really gives you an in-depth experience, not just in the meteorological part, but also what it was like in Marsh Harbor after. It's fairly grim, but it gives you a good idea of just the scope of this impact.
It's an exciting, but also a very catastrophic view of storms and the human impact that it has. And a lot of us are in the business of dealing with the aftermath. And we thank you for allowing us to see just how damaging these storms truly can be. I don't see any more questions other than great presentation. Thank you so much for sharing your experience. So Josh, we thank you, along with the other speakers we have for our general session today, Phil Klotzbach, Ken Graham, Pete Gaynor from FEMA, Ken from the National Hurricane Center, for taking the time and sharing it with us. It's one of the first time we've ever done this virtually, and it's been an interesting experience for me as a moderator. And if I can get you to change the presenter back to me before you leave, I'd appreciate it, so that I can, thank you, sir. And I can go ahead and complete this webinar. Thank you all who attending this general session. And there's another one this afternoon that starts at 1:30 Eastern Daylight Time. Again, thank you, Josh.
Thank you, my pleasure.
And thank you all for attending.